Hello, hello, and welcome back to the Advent of Code. And it is day 10 today. There's just 3 days left. And I heard today is a hard one. We'll see about that though. We'll see about that. It's probably easy. It's probably actually easy, right? Hello, Nigel. And Nerdcell. Let me see if I have all of my things updated here. I worked on the language yesterday a little bit. Hello, Picorli. Bash is better. Why is Bad Cop still live? There a stream when you woke up? Because apparently day 10 of Advent of Code is difficult, doesn't have a linear algebra solver. Alright, yeah, so like I heard that there's something to do with linear algebra today, but we'll see. I don't actually know this solution or the problem statement. All I know is that Bad Cop is struggling. Okay, so I just updated cast to the latest version here. Hello, Veldek. Have you started doing the Advent of Code, Veldek? You were going to, right? Alright, let's open day 10. Day 10 will start like that, like so. Workspace. How do you duplicate line? Line. Copy line down. Control Alt Shift down arrow. I will just select a line and then copy it. Not yet. You'll start on Friday. Okay. Okay, so here we go. Day 10. We are ready to read the input. Let's read the problem statement. What is it about? Just CC, CV. You don't need to do X when you copy. Control C. Just copy the line by default. I thought you were doing Helix. What do you mean? You just Control C, Control V. Oh, does it copy the whole line by default? Control C, Control V. Oh, it does. Wait, what? Really? How do you know that? If you are a Helix user. Okay. That's actually good to know. Alright, day 10, factory. We know all about factories, right, Veldek? Alright, so for example, we have this thing. Example txt. The manual describes one machine per line. Each line contains a single indicator light diagram in square bracket. Indicator light diagram, or one or more button wiring schematics in parentheses and voltage requirements in curly braces. To start a machine, its indicator lights must match those shown in the diagram, where dot means off and hold on. To start a machine, the indicator light must match those shown in the diagram. Indicator lights is the diagram, which is the square brackets, right? So like this means off, this means on. The machine has the number of indicator lights shown, but its indicator lights are initially all off. So we need to do this to start the machine, right? Okay, we need to match this. Okay, so an indicator light diagram like this means that the machine has 4 indicator lights where they're initially off, and the goal is to simultaneously configure the first light to be off and the second light to be on, And yeah, you can toggle the state of indicator lights by pushing any of the listed buttons. Each button lists the indicator lights it toggles, where 0 means the first light, 1 means the second light. Okay, makes sense. And then what's the curly braces mean? So a button wiring schematic like this means that each time you push that button, the first, fourth, and fifth indicator lights will be all toggled. If the indicator lights were this pushing, this would be that. Because none of the machines are running, the voltage requirements are irrelevant and can be safely ignored. You can push each buttons. You can push each button as many times as you like. However, to save on time, you will need to determine the fewest possible presses required to correctly configure all indicator lights for all machines in your list. There are a few ways to correctly configure the first machine. This, sure. That's just the definition of the first machine, right? Okay. The second machine can be configured with as few as 3 button presses. Okay, so we just, I guess in the first part, we just ignore this joltage stuff, right? If I was to guess the part 2, it means that I guess like the cost of the turned light per second or something is the joltage, right? So we need to keep them for as like when you turn the machine on using the lowest amount of energy or something, maybe. All right, but we'll get there. Let's do the part 1 first, right? Okay. Download the input. Download the input, day 10 input txt. And let's immediately see how many lines do we have here. Day 10 input txt. How many lines do we have? We have 200 lines. The number of lights in each machine is very, very small. Yeah. Very small amount of lights in every machine. Okay. What's the problem? I mean, I don't know. We'll see. What's the problem? Well, I mean, how do we solve this, right? How do we solve this? We need to figure out the minimum amount. Well, I mean, yesterday, one of the things that I did was literally the bitwise operations on integers. So it's going to be... we can use that. We can use the bit masks to represent the current state of which lights are on and which lights are off, right? And then since from what I see here, we have at most 10 lights. That will be that means that the amount of different states that the thing can have is just 2 to the power of 10, which is just std op bit shift left. So like 2 to the power of 10 is just 1,000, right? So we just have 1,000 different states, which is like nothing, right? So we can just iterate over all of them. And so to do the minimum thing, we just do the normal stuff. We just do the normal thing to calculate the minimum amount of steps, which is the BFS, right? For this first step. Okay. So what's the problem? I don't know. We'll see about part 2. Maybe there is something different than what I imagine these numbers are meaning. I feel like BFS should be really easy. Okay, so we just do string lines input line into something line. What do we do? So for each line, we need to parse it first, right? So we do target state, buttons, and like joltages. Okay, do you have an interpreter for now, or it compiles to something? Will light LLVM be useful to you, or will use LLVM for later anyway? Right now I have interpreter. Right now it's not compiled. The plan is to use lightweight LLVM, which is called JavaScript. So transpiling to JavaScript is the goal. But long term we will have to use LLVM so that the binaries are fast, because LLVM is like, as far as I know, the thing that you have to use if you want to have a language that's fast, right? There are other alternatives. I know of QBE and CraneLift, which are easier than LLVM. We might consider those. In general, though, the idea is that doing the backend, different backends, should be easy enough so that it's something that maybe not even I am going to implement, but somebody else. The idea is to make it easy for users of the language to implement their own backend. We want to have compiler as a value, compiler as a library, basically, right? And we want, that's the plan, basically, right? Because I want to also use this for like GPU programming, for doing shaders for games. So like I will probably like transpile this to GLSL, or I don't know, maybe some other things. We'll see, Spear V, like whatever, you know. Yeah. Anyway, let's just do. So here I need to like parse the line, parse machine, I guess, line, target state, buttons, and voltages, like that. Okay. Ooh. Just writing my own backend like QBE for JITs for my compiler, and thought it would be useful for anyone. Yeah, like I think that like one of the things that we have a problem with right now, like especially when I'm doing this inventive code, is that the interpreter is really slow, right? It's like 100 times slower than Bash, and like Batchcop I heard is having big problems with like in this one in the day 10. Right? So one of the things that I would want to look into is the JIT of the interpreter. Although at the same time, I'm not sure if I actually need it, because interpreter is intended not for like actually running programs. It's intended for usage for compile time evaluation, right? It's just like right now I don't have any other alternative, so that I'm using the interpreter. But I will. So maybe it's not needed, but like, but since still, if I do JIT for the interpreter, since interpreter is used at compile time, it means that compilation is going to be faster, because interpreter is going to be faster, because the compiler is the interpreter, you know? Okay, parse machine is a function string into, so I need to return the machine here. Machine is type where we have a target state, which is just state, I guess, right? State. By the way, speaking about like languages, like, so right now and like in this advent of code, I've been doing my types with capital letters. I should be consistent. All of my types should be capital letters then, right? I feel like we should do that. So right now, everything in the standard library is actually lowercase. So state, I think, is just going to be an int32 for now. So buttons is the list of what? The list of button. So button is the well, I mean, technically it is also another integer where every bit is going to be like every bit is which is set is the light that is going to be switched, and we're just going to use the bitwise operations here. Yeah, it's like we knew that today is going to require bit operations, and we implemented it yesterday. Nice. So this is just going to be state. And then joltages is a list of like integer or whatever. If interpreter is tag-based, yeah, otherwise you need additional lowering layers to transform interpretation to basic constructs from more basic backends like QBE or LLVM. Yeah, there's also like WebAssembly, for example, that exists. WebAssembly is pretty low level, but it still is stack-based. Yeah. And then we can use some existing like thing for WASM. Also, probably. That's like there's a lot of things to consider. Right now, I'm not really like worried about that though. But yeah, it's not going to happen very like very soon. Probably. I mean, we'll see, because I want to rewrite the language in itself, right? And for that to be usable, I want it to be relatively fast, right? So I don't know. We'll see. We'll see. Okay, so first thing here, by the way, I need to do if line, if string length line is 0, then I'm just going to return here, right? I have a working LSP. Well, I mean, I feel like the LSP is a little bit weird. For a lot of languages, they do LSP as a separate project. For me, LSP and the language is like the single thing, which makes it a lot easier. I'm not sure why other languages don't do it like that. You know, like I already have all the information when I'm compiling, and now I just need to give it to the editor. Why does it need to be a separate project? Because most languages predate LSP, but there are a lot of languages that are new that are still doing it separately, like Zig, for example, right? It also ends up LSP re-implementing like the language almost because of like compile time evaluation in Zig or whatever, right? As far as I understand. Parse machine line. I wanted to do something. I noticed that my LSP is relatively slow right now. It's probably because I'm parsing all 10 days currently. So maybe I should comment out the first 9 days so that I have a better experience. Yeah, this seems a lot better now. Okay, yeah. This is like 10 times faster now. Yeah, I like it is it wasn't still not like very slow, but I didn't even start optimizing things. I'm still compiling the entire thing from scratch every time a single byte changes. It's like absolutely not incremental. All right, we want to parse the machine string into that. What are you saying? Type tuple. This is not equal to main machine. Hold on, does that not work? Is it because of the structuring here, though? It is. Interesting. So the problem is, like, I added named types, and this doesn't type check, because it thinks that this type and this type is different types. This one is called machine, and this one is kind of like anonymous, but it was supposed to merge their names, which is weird. Oh, or maybe it's because, wait, hold on. It's because I have this. I have a typo, that's why, right? There we go. Never mind. It's because I did a typo over here. Okay, we have a machine, right? So first that we need to do, we need to like just split over the white space, I guess, right? So we do string split as space part into like whatever. Is that how we do it? Yeah. Okay. Let's see. So, let's see. Target state is 0. Buttons is list create. Joltages is list create. Over here we return target state, buttons, and joltages. And to do for a better error in that case, to do should not be here. Like, we should actually start using the issue tracker on cast, I think, for the things that need to be improved, right? I remember though this. I remember like one of the problems with the named types. This is like specifically when the tuples are not equal, you need to look into like which fields are present and which fields are not present, right? Like this is the information that we want, right? Give extra information. What is the field that is not present in like the other type, right? Or something. It's okay, I will force him to do proper error messages when he starts writing in cast. Yeah, I think like when I rewrite the language in itself, I want to like we want to take it slowly, make sure that there is I'm not the only one who understands the code maybe and stuff like that, you know. Maybe like write a blog about how we implement the thing as we go, so that you can read it and like understand the implementation, I guess. And try to make the actual code look nicer instead of rushing like I'm doing right now. It will take a lot of time though if I do that. So I don't know. There's like the trade-off, you know. We either work on the language quickly, or we make it like nice looking code and like you know, understandable code. Like right now I'm in the prototyping phase, so it makes sense to do what I'm doing, right? Okay, so if string at part 0 is equal to opening bracket, right? First, working quickly is an illusion. Look at Linksider. String at part 0. This over here is a little bit weird. This is the problem. Like it thinks that these and these brackets are matching here, right? That's the problem with what? With the VS Code extension. I guess. Parents. Okay, so if parents is this, then we do one thing. If parents is round bracket, then another thing else. If parents is curly brackets, then other thing else. Panic. Unexpected character. Right? Like so. Okay, so if we do the opening bracket like this, then we also want like the actual thing to be a string substring of a part starting from 1 and string length part -2, right? So this is the actual content inside of the bracket. Inside So yeah, over here we just do what? Over here we just do what? We just do string iterate inside. Type shape. Yeah, we need like character. So C into what? So we just say that target state is std operator binary bit shift left target state 1, right? Plus C, where C is if like I guess if C is hashtag then 1, else 0, right? Something like that. We can do plus, we can do bit or. I don't have like the syntax for the bit operators, but it's okay. We just do that. Okay, so if parentheses are round brackets, then this is my buttons, right? So this is buttons. Okay, so like affected lights is 0, right? And then we go string split inside with a comma. We have a index there, which needs to be parsed, right? So index is index parse, which is an int here. And then we just say that affected lights is std op bit bit or, right? So I need to add this light. Are they always in order here? I mean, it doesn't matter, right? We just do bit shift by the index of the light. Wait, hold on. What's the order here? This one is 0. This one is 4, right? So like this is the most significant or like least significant bit, right? So 0 like that. So this is bit 0 still, right? For me, yeah, I think. So we do bit or of affected lights with std op bit shift left. So I'm just bit shifting 1 by index, right? Yeah, and then I do that. Makes sense. And then this is my affected lights, right? So we just do buttons list push back into buttons. I add the affected lights. Okay, and last we do the joltages, right? Joltages, okay. So we say that string split inside by comma x into x is x parse, and then we say list push back joltages x parse. I mean, just inline this here. Can do that, I guess, right? So yeah, let's debug print the input, right? Parse machine. Let's just do. Let's say okay. Let's say that this is machine, right? Machine is this, and then we destructure it. I don't know if I need to. Maybe I don't need to destructure it. Whatever. We just want dbg print machine for now. So this is just me reading the input, right? Day 10. Nice. Unexpected equal sign over here. Oh, because not is now the thing that we have. This is the proper like syntax now. I don't need to implement it in my advent of code anymore. Okay. Holy wait, what? Me parsing the example is this slow. Wait, really? Wait, really? Hold on. Is it that slow? 8 seconds to parse example txt, which just has 3 lines. Wait, what? That makes no sense. Why would it be that slow? What? Excuse me? There's no way. What if I do input txt? Can you parse me a line? Is it the string split which is actually slow? Hold on, string split. Let's see. Maybe like string split actually is slow, right? Because how is it this thing implemented? It's implemented like that, right? Inside the language itself, which also uses this function, which is also implemented in the language itself, iter. This one is the only native function. And then we do that. Yeah. I mean, that's a normal implementation. It still is not... No. Am I cloning strings? Well, I mean, I am. But does it matter? Like, this is still supposed to be really, really fast, right? That's... something is really wrong here. Maybe that's why my language is slow. I need to figure out what is the problem. What is the problem? Let's do profile. Profile the day 10. Oh, I forgot about my thing, by the way, like always. We're solving day 10. Oop. All right, let's open Profiler. What is it going to say? stdleap map add. So there's like a bunch of me adding things to the map, right? Cast inference base unite data. What data? Oh wait, unite data list? Wait, there is no way. Wait, it's because I am uniting the list, right? Which is the value itself. But why would I ever do that? That makes no sense. Oh wait, we unite data list iterate. This is me calling the functions on the thing being inferred. String map add, right? stdleap map add. What am I adding to the map? What? This is during the inference. During the inference means that it's not even... Wait. Like, this is not evaluating stuff. Right? This is not evaluating stuff. Call GC. Wait, what? Call GC is 50%? Stack. Inference, unite data, iterate, check unite, map add, ID compare, ID compare. So it's a map which stores IDs. But this is inference, which means that this... Wait, what? That makes no sense. Hold on a second. Maybe printing? Hold on, there's no way. Like, maybe printing takes a lot of time for some reason. That makes no sense though. Hello, Dev Ninja. No, it's not the printing. There's no way it's printing. But I mean, I don't understand what can take this long time. What? Why is it still running? Wait, memory? Wait, is it killed? It's killed. Wait, it's used too much memory. Wait, I feel like we have a bug, but I don't know where. Like wait, no, this is input. This is input txt. I see. All right. Well, I mean, I wish we went into solving the advent of code, but we have a problem here. Wait, but the reason, like, because I'm leaking memory, it means that, like, since I'm not storing this machine anywhere, right? Like, how am I leaking memory? I'm, like, discarding the machine, right? I'm not storing these things in the thing, you know? So, try coming out the BG print. Yeah, this looks like leaking, also for no reason, right? dbg print, like, I'm pretty sure that's not the thing that's slow. It's not. 8 seconds, okay. Let's comment out this, let's comment out that. So, like, the only thing that I'm doing... So this takes 2 seconds to just do that stuff, right? Is it because bit shift left is slow or whatever? That wouldn't make a lot of sense, though. That would not be making a lot of sense. 2 seconds. 2 seconds if I just split my lines over commas. Yeah, okay. And this is still 2 seconds, right? Yeah. So this is the same. String split. So is the split the incorrect one? Probably, right? So I have the problem with my split implementation. We just iterate over the string. If we see if this is a separator, then we just perform the split at index I. That's all, right? That's all that we do. Iter I sounds like illness. All right, let's also try this thing because there's another thing that I can do. We can do cast profile trace JSON source day10 main KS. It's not perfect, but it's going to do something for me. We can see, like, we can profile based on, like, cast code, not a camel code. We open Perfetto, right? Perfetto dev, is this the one? I guess. Trace viewer. UI Perfetto dev is what we want. Open trace file. Projects, advent of code, trace JSON. All right, let's see. So what are we doing? Yeah. So this over here, this is string. This is string split. String split is line 62, right? Line 62. Wait, hold on. It says line 59 to line 52 to 59, which is this, which is lines. Okay, that makes sense. So like this, in general, is me iterating over the lines of input, right? And then split is this. No, this is 60. 60. This is just end line. Okay, that makes sense. Okay. STD string. STD string. Is there something in main KS? There is over here. Main 62. Main 62. Advent of code main line 62. This one, parse machine. I mean, yeah, so like this call is slow call, right? That makes sense. But there's still like, as you can see, half of the code of me basically splitting the thing, right, is still inside of the lines, right? It kind of makes sense. There's like a lot of small things here, I guess, which is really slow. And what is this? 62. Also 62. So it's like the same function. Yeah, okay. So this emptiness is the overhead of the string lines, basically, right? Which is a lot of overhead, I would say. To iterate string splits somewhere. String lines is implemented using... Wait, hold on. String lines is not implemented using the splits, by the way, which is weird. It should be implemented using splits. I guess it's because this one... Yeah, I implemented this later. That's why. How are you storing functions? It's not because of how I'm storing the functions, because like this is implemented in the language itself, and a lot of this and this is like slow for some reason, right? Iter I is because iter I is implemented like this. I is I plus 1. And iterate is the native one. Iterate is the native one, yeah. Closures. I don't think it's the storing of the closures. It's just that this has a lot of code and it's really slow to interpret it. But 8 seconds? Like, how are my previous days were not that slow? Like, it doesn't make sense, right? Or, I mean, maybe I broke something yesterday then? Let's just try, let's just try day 9. Like, on the example, right? Day 8. It was never this slow. On the examples, right? I broke something. We need to, like, see what's changed. I'm gonna assume that this should work properly. Trace, let me ignore the trace. Okay. Day 10, read input. Okay, can I just like git checkout had like previous commit? Previous commit, so previous version of cast. And then we just do cast. And then we just do day 8. Like, you see how this is fast, right? So the only difference is the version of cast. So I just updated it and it became 1,000 times slower, and it was already slow yesterday. Okay, what did I do in cast then? I didn't do anything that would make the language slower though, right? We had more escape characters, better implementation of op equal, unary, minus, and plus, not operator, rem operator, bitwise operations, float 64s, polymorphic natives. Oh, wait, is this the one? Wait, this probably is the one. Let's do the bisect. Let's do bisecting. Git bisect. Git bisect start. Git bisect. Good. Good is just like had, I guess, right? And no. Hold on. It's bad. It's bad. Bad had. Git bisect. Go like bad is had, right? Git bisect good is from yesterday. I mean, I'm pretty sure that this is the one. Let's just copy this, you know. Let's do git check out, git bisect reset, git check out this. Okay, cast. Day 8. Let's just run day 8 here. Unexpected equals. Well, it's because it already had the not operator, right? I guess if I check out this, this is going to run properly. Right? Okay, that's fast. Git check out main. So we're back to day 10. Now it's going to not find the not. Let's check out this thing again. Run that. No, that's not the correct. Like, I want to check this commit. Pretty sure this one is going to work. Fast. That's pretty fast. And then we select the next commit, polymorphic natives. And polymorphic natives is not going to work. It's going to be really slow, right? Wait, it's not. Okay, wait, I have no idea then. Tuple assignee expression. Let's just check out these last 3. Or whatever. You should go on Twitter and blast the cast dev. Okay. Maybe I should have just done the bisecting then. That still is the same speed. Right? Fix AST as place expression. Gen range. Oh, is that the reason? Hold on. Oh. Is this literally the reason? So literally the last commit then. It is the last commit. Look at that. What? I'm sorry. It's just not even doing anything. Input red in 1 billion. Okay, so what is in the last commit? Let's see. The only thing that I did is like, instead of only being able to generate random integers, 32s, I can generate like this for any type. Right? Okay, maybe this is the reason, because substituting okay, maybe that is the thing. Hold on, substituting bindings. This. But because previously I was not substituting the bindings here, right? Is that the problem? So that's because we are using trips for lists right now, and I changed the gen int32 into gen range, which is just with the polymorphic function instead of the concrete function for integers. Right? So that's the only reason, the only difference. So I'm waiting for the type to be inferred, but it should be inferred there. And then based on the type, we are doing the random generation depending on the type, which makes sense. Otherwise, the code is the same. So the only extra difference then that I see here is that I'm substituting the bindings, right? Okay. Let's see. So it's just the interpreter common. Expression native. This over here does substitution of the bindings, right? Okay. And that is slow. Substituting the bindings of this entire thing. It is slow. Yeah, that makes sense. How do I make this not slow? I cannot store it directly in the expression itself to do it lazily and only once, because I reuse the same expression. I cannot not substitute the bindings though. Because then I will just have the generic variable t here instead of the int32 that I'm trying to like generate in that case. So this should be stored inside of the current like because I'm calling a function all of the natives can be like it's like similar, yeah, similar to jitting, whatever. Like I need to like just in time substitute it, because like doing it over and over every time makes no sense. Good night, Nigel. I mean, I can go back to the previous version of cast for now and just do the advent of code first. Is that a good thing to do? Maybe we do that later. Okay. Fix the performance. Isn't that essentially doing monomorphization? Yeah, I think it's like doing monomorphization at runtime, I guess. Like just-in-time monomorphization, I guess. Right? Is what we want here. I mean, this literally is monomorphization, right? But it is doing monomorphization basically every time I call the function, which is why it has a huge impact on performance, I guess, here, right? Because it needs to traverse the entire type of. In this case, I'm doing this just for native expression, so it's not like that big, right? But yeah. It should not happen at runtime at all, right? But I need to do that to figure out. Yeah. I don't know. I'll think about it. But just for now, revert. Can I do something like nix flake update cast to a specific update? Can I update the input to the specific revision? Can I like update cast to this revision? No. I mean, I can change the log file manually, I guess, maybe. It has the nar hash too, though. Hold on, let me ask ChatGPT. How do I fix my flake input to specific revision command line? Nix flake log update input override input rev, or if you know the exact commit, override input. Override input. Override input. Okay. Cast. GitHub. Cast lang cast. Revision is this? Nope, not that. Hold on. Revision is that. No matches found. I feel like it should not be a oh wait, it's a Zesh. It quotes here, right? Okay. I'll need to take a look at this after. Okay. Let's see, day 8. Still reasonably fast. And now day 10. Day 10 is instant. Okay, there we go. Wait, unless I commented things out. I commented out the printing. No, I only commented out the printing, right? So yeah, there we go. It's instant. It's literally like, the difference is literally 1,000 times, it seems, right? It's either instant or it takes 8 seconds. Yeah. We'll have to look at that. Okay. Let's not print because this is printing the whatever, the trip under the hood. Okay, I have read the thing, right? I have read the input. Now we just need to do the BFS, right? We need to solve this thing for the machine, right? So we need to store a queue. Use std collections queue, right? So I say that queue is queue create, right? Queue, not go there. I need to like make this look differently, maybe. Queue. Queue. So we want to queue to push the current state. The current state is just 0, right? 0 is the starting state. Q push Q0, right? And we do while Q length is not 0. We want to say that the state we want to pop from the queue, right? So this is still an integer. And now we want to try pressing all the different buttons, right? Also, I want for all the different states, I want to have basically a map from a state into the a map from state into the distance, right? How long is it to reach it, right? So distance is, let's see, I'm just going to use the list, I guess, right? I need to figure out how many different buttons, different lights we have, right? Which is, let's have the amount of lights, right? Lights. This is just the amount of lights. You know? I'm just going to say that lights is the length of the inside here, right? So lights is string length of the inside, whatever. Okay. So I just do for this in 0 to I need to do 2 to the power of lights, right? So std op bind bit shift left 1 to machine lights, right? Differences here, yes, and then we just do we do list push back d0, right? Not 0, let's do -1 here. So -1 means that it's not visited or whatever. Yeah. Okay. So we push the 0, and I also say that list at 0 is 0, right? I just need to like what the fuse button press is required, right? So this is going to be literally the answer, right? So in the end, what is the fuse button presses required to correctly configure the integrated lights all the machines? So I just need to say that answer plus equal list at the machine target state, I guess, right? And answer is here is 0, and we dbg print answer in the end, right? Okay, so over here, I'm just going to do this just to check, right? If machine answer is less than 0, then panic. Couldn't solve the machine, right? Or whatever. Less than 0. So right now it's going to say that couldn't solve the machine, obviously, right? So we need to solve it here. When I'm popping the state, I need to find all of the neighbors, right? Which is just me trying to press all the buttons. So we need to do list iterate all of the machine buttons. So this is the changes, right? The changes that are going to happen, and I'm just going to say that new state is std op bit XOR of state and changes, right? And then we need to add this to the queue if it was not visited, right? So let's also say that state d is list at d key state dereferenced, right? And the new state d is list at the new state dereferenced. So if new state d is less than 0, then we say that let's not dereference here, actually, let's do this. So we take it by that, and then we dereference here. If it's less than 0, then I say that new state d is state d plus 1, right? Like this. And then we do q push Q new state. There we go. Reference. Couldn't solve the machine. Okay, sure. I did something wrong, I guess. dbg print state. Okay, so this is all the states that we actually got to. So first we start at 0, then we have 8, right? Why do we have 8? Why do we have 8? Because the first button that we have is 0, 2, 3, and 4. Right? Which is not 8, right? It is, if this is on and this is on and this is on and this is on, this is like 2 to the power of 5 minus 1 minus 2, right? Whatever that number is. It's not 8. So how about we actually debug print what I have read then? Let's do std collections trip to string machine buttons inner so this is going to be an integer here, right? Yeah, we just say toString acts here. Let's do that. And then we do print this. Sure. Okay, so the first yeah, I just parsed my buttons incorrectly then. Okay, which may actually probably should be maybe like over here. Target state. Let's do over here. Print. Red. Target state b toString target state. How about that? Am I reading target state even correctly? Target state is 6. Is that correct? This looks like not 6. If this is the only hashtag, this is not 6. This is 1, 2, 4. This is 8, right? My target state even is not correct. As BFX for plus XOR for neighbors too, yeah. I mean, is there another solution? I mean, you can do it without the bit operations and do like the slower. This is just an optimization, right? But is there any actually other solutions? I don't know. I didn't really think much about other possibilities. Why am I reading stuff incorrectly though? Target state is bit shift left, target state 1 plus C for every character C, which is of the inside, and inside is print inside. Just to make sure. Wait, what? Oh, wait, wait, what? Wait, what? Example of day 10. Day 10 example. Wait. Never mind. This is not what I'm reading, right? This is my example. Okay, this is my example. Okay, nice. So this is actually 6. Okay. And this is 3, which means that we have 8. Okay, the 8 is correct here. Okay, never mind. Never mind. This is correct. I was looking at the wrong input. Okay. Okay. So my target state is 6, and I never actually... Wait, hold on. No, I did get to 6. Okay. And then I get target state is 2. This over here is incorrect. Its target state is not 2. I need to iterate in reverse order, right? So yeah, this over here is not... yeah, I'm reading my state incorrectly. I'm reading my state in reverse, right? I cannot do iterate reverse though. I cannot iterate reverse, but I can, I guess I can do this manually, like for I in 0 to string length inside dot rev. Do this, right? Do I have that? Dot rev. Is that a syntax that I implemented here? Yeah. Let's bring this syntax here. So that we can... Maybe I should put that into the standard library for now. But yeah, we have we iterate reverse, and then I just say that C is string at inside I, right? And then we do that. Okay. There we go. So the answer is 7. Is that correct? It's 7. Okay, nice. dbg print state. Let's remove that. Okay. It's relatively slow for the example, but let's see for the actual input. Is it going to be slow? It's a little slow, I guess, still. Okay. How many lines do we have? How many lines do we have? Oh, holy shit. Yeah, I need to... You know what? Let me just unlock the memory to 10 gigs. That sounds reasonable, right? Yeah, 1 gigabyte is not enough for me in any of these problems, but 10 gigabytes will be enough for sure, right? I want this, yes. Fast is using 2 gigs right now. There we go. How many lines are there again? Say 10 input. There was not that much, right? But it is 200, and I only parsed 10 lines so far. Okay. Ah, shit. Okay. How do I make this faster? How do I make this faster? Without changing much in the language here. Changes is this. I just need faster lists. Like if I had native lists, native arrays, I mean, right? That would be a lot faster. I mean, we can also try profiling, I guess. Over here, maybe there is like some similar bug to what, like to that other one. There's no way I can wait for this to end, right? I mean, some of them are really done quickly, though. There is one way to improve this. One way to improve this would be to do the BFS from both ends, actually. This is supposed to, like, probably cut the stuff in half, right? So we do the BFS at the same time from the start position and from the target position backwards, and then we meet in the middle. And when we meet, we like add the things together, right? Also, wait, hold on. Also, I'm not stopping when I reached my target. That would be the easy optimization. Also, because if my state is equal to the target state, I don't even stop. I continue my BFS. So I actually try to calculate all the reachable states, right? Which is useless. Let's at least not do that, right? So if state is equal to machine target state, then break, right? That makes sense. Let's see if this is just going to be a lot faster or not. Is this even faster looking like? I don't know. But doing BFS from both ends sounds also like a good idea indeed, right? Yeah, but the question is though, like, I don't want to do another list. Can I do over here something like print info starting BFS? Just so that I see, like, after I read. Right, I want to print info red machine number to string index. Let's do that. Let's keep the indexing here, right? Index is 0. Index plus equal 1 in the beginning. Okay. Yeah, see, like, it's not starting the BFS immediately because just even constructing the empty lists like this is slow. What we can do, I can, like, I can still work with trips, but, like, initialize it in linear time instead of log n time, maybe. There is a way to do that. Do I want that though? Maybe let's just do the BFS from both ends. So maybe, like, we store positive integer for the ones that are forward paths, and we store negative integers for the ones that are negative paths. Anton Shushka, hello, здорово. The spark effect is called the power mode extension. It's just an extension for VS Code called power mode plus, I guess. Yeah, and then, like, let's and then, like, 0 is actually going to be the thing that 0 means that I have not been there at all, right? Which means that for the starting one, I'm going to say 1 and not 0, and then I'm going to subtract from this thing 1 in the end, right? Yeah, that makes sense. Okay, so I'm going to queue push this, and I'm going to also say that at machine target state, at that machine's target state is going to be -1, and I'm also pushing to the queue the machine target state, right? So we do BFS from both ends. Okay. So over here, we have not been there if this is equal to 0, right? But then the new state D, is state D plus plus direction, where direction is if state D is less than 0, then a -1, else +1, right? Okay. And if new state D has been visited and it has the opposite direction, I think, right? So over here, else if new state D being less than 0 is not equal to state D being less than 0, which means that they're opposite directions, right? Then trying to compile error node. Change parenthesis here. Do you want parenthesis here? Do you want parenthesis here? And here. Wait, why? Well, because the last then has the same priority as not equal. That makes sense. Should it have different priority though? I guess it shouldn't, right? I just need this parenthesis. Makes sense, I suppose. So if they have different things, then this is my answer actually, right? Then this actually is my answer. And then let's just say that machine answer is -1 originally. And then over here we say that machine answer is absolute of state D plus absolute of new state D. Right? We still don't have the absolute function. Absolute x is if x is less than 0. I cannot do that. X into if x less than 0, then -x, else +x. That's x. Couldn't solve the machine. Okay. Can I do the example here? I couldn't solve the machine. Okay. Starting BFS for machine 1. Okay. Machine answer is this. If new state D is less than 0, is not equal to this being less than 0. Then machine answer is that. I'm just starting at both ends. Machine target state. Oh wait, state is equal to machine target state break. This is no longer needed here, right? I no longer need to break because I'm breaking over here actually. And let's do the breaking then. Well, I mean, I can do the breaking from here. I guess I can do breaking from inside of the closures, I think, right? There we go. Wait, but this is now saying 10. Is that not the correct answer? It's 7, right? I need to do... Yeah, I need to do like -1 here. Because, yeah. Because we start counting at 1 and... so, yeah. So there's like actually 2 extras, but then we did not count the current button that we press. So like -2 plus 1 is what we want, which is just -1, which is gives me 7. Okay. Input txt. Let's see if this works better. Number 10, 11. I mean, this is something that we probably can wait for, right? It's already 20, which is 10% of the entire input, right? We can wait here. We can wait. Did Bad Cop give up? Or did Bad Cop solve the thing? Or is she still streaming? Oh, still streaming? Lol.
No way.
Is part 2 like 1,000 times harder than part 1? Or something? Or Betcop is just having the performance issues just like I have? A billion times? Alright, let's see what it's about. 66. Okay, we're getting there. BFS explodes. Yeah. Well, I mean, I already know. I already know kind of because I've visited Betcop's stream what the... I mean, I don't know the exact solution or like why. But I heard the word linear algebra. And there's a hint, yeah, Gaussian, like, whatever, like, thing, elimination, right? To solve the list of equations. So, well, I have been spoiled a little bit, but it's okay. I still don't really know, like, because I was assuming that the part 2 would just give, like, joltages is the oh, wait, hold on. Never mind. Like, I was thinking that joltage is like the power that the light uses, like every second or whatever, and then we need to minimize the power usage. Is that the actual thing? Probably not. No? No, okay. Did I time this thing? I did not time this thing. Do I restart with timing? No, I don't. And I should not have been using int64s here, right? No, I should not, because we have at most 1,000 states and 200 lines. Yeah, it fits into an integer. We're okay. Oh, no, shit. Wait, what? I just used 10 gigs of RAM? Wait. That means that I have a leakage, though. Because I'm not storing this stuff for previous ones. Okay. That's bad. Time. Yeah, it's a memory leak, I guess, somewhere. But, like, I'm not storing, like... I'm not storing the queues. So they're supposed to be garbage collected, right? Rajora. Oh, yeah. I mean, the queue... Yeah. Like, all of these things are supposed to be garbage collected, right? So, that's weird. I have a bug somewhere is what this means. Let's unlimit the memory, I guess. So right now we have 20 gigabytes available to us, right? We can spend 20 gigs for this problem. I guess 10 was not enough, but we can do 20. Okay, so right now we're using 2.4. I feel like the graph of memory was better in my bottom though than the B top here. Can I change this to like be the graph? of RAM. How do I switch the tab? Just tab? Mem. Mem below net. Mem graphs, true. I mean, it is showing the graph, it's just like, was a lot more precise, I guess. My memory interface even. This one. What was it again? Oh my god, 5. And interface. Yeah, and P5S0. I feel like it's showing my internet usage incorrectly. Download and upload is exactly the same. This is a bug. I mean, not a bug, but it's like monitoring something different. Machine 140. I'm using 10 gigs already. Okay, yeah, okay. Yeah, this is a leak. This is a leak. This is a leak. But I still have 10 more gigabytes that I can give my program. $170. Just 25 more. $12 gigabytes. Here at the end. It's almost done. 13 gigabytes. And it's done. Okay. 5 to 7. Oh, is this 4 minutes and 40 seconds, right? 4 minutes and 40 seconds it took us to calculate. Is this even the correct answer, though? It is the correct answer. All right, let's just see the part 2 immediately. Day 10, part 1. Is it day 10 today? Yes, right? Part 1. So all of the machines are starting to come online. Now it's time to worry about the voltage requirements. Each machine needs to be configured to exactly the specified voltage levels to function properly. Below the numbers on each machine is a big lever that you can use to switch the buttons from configuring the indicator lights to increasing the voltage levels. Ignore the indicator light diagrams. The machines each have a set of numeric counters tracking its voltage levels. One counter per joltage requirement. The counters are all initially set to 0. So joltage requirements like this means that the machine has 4 counters which are initially at 0, and that the goal is to simultaneously configure the first counter to be 3. Okay, makes sense. So it's instead of binary, it is now instead of binary, it's now not binary but numerics, right? The button wiring schematics are still relevant in this. So like button is just increasing the counter by 1. Okay, makes sense. Makes sense. Can I decrease it by 1 too? Each button now indicates which counter it affects, where 0 means the first counter, 1 means the second counter, and so on. When you push a button, each listed counter is increased by 1. So button wiring schematic like 1.3 means that each time you push that button, the second and fourth counters would each increase by 1. If the current joltage levels were this, then pushing the button would change them to be 0.2224. You can push each button as many times as you like. However, your finger is getting some sore from all of the button pushing, and so you will need to determine the few still presses required to correctly configure each machine's joltage levels to match the specified joltage requirements. Consider again the following from before. This requires a minimum of 10 button presses. Okay. Analyze each machine's voltage requirements and button wiring schematics. What is the fewest button press? So like there is not even no limit even, right? So we can, but we can only go positive. Okay. Yeah, so basically if we assign a variable for each of the buttons, like how many times do we press this button, right? Then in this case 3 for the first one, right, should be so 3 should be equal to the amount of times we press this button plus the amount of times we press this button, right? That's all. That is all. So we have a set of equations where the sum of some of these variables is equal to this. That's all, right? So we have actually a very simple system of equations. All right. And then we just solve that equation. But the equations, they can have multiple different solutions, right? But what we want is to minimize the total amount of the times we press this button. So like we want to minimize the sum of the variables basically, right? So if we have some free variables, become some free variables, is it always the most efficient thing to set the variable to 0? Or is that not always the case? Right, so in this case, for example, right, we have so like A is the first, B is the second, A is 1, 3. So this is the first button, A, right? The second button, B, is just 2. The third button C is 2 and 3. The D is 0, 2. E is 0 and 1, right? So we say basically that because 0 is just D and E is equal to 3, right? We say that 1 is A and E is equal to 5. We say that 4 din, 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 din. 4 I mean 2 is just B, C, and D is equal to 4, right? And then we say that 3, which is A plus C, is equal to 7, right? So we need to solve this sort of equations. We have 4 equations, but we have 5 variables, right? Which means that one of them is free variables, is free variable, right? So let's first say that if instead of this, we're going to subtract that from that. So we're going to say that C minus E is equal to 2 instead of like one of these. No, right. Let's convert this to the matrix view, right? So so we say A, B, C, D, E is equal to 3. We say that A, B, C, D, E is equal to 5. A, B, C, D, E is equal to 4. A, B, C, D, E is equal to 7. Forgot about 3. Oh, there is also 3? Okay. Let's call this one F. F is 3, right? In this case, we do AC plus F, right? So we add the column of zeros here then. Right, so this is my 4 equations that we need to solve. Let's reorder them like this, right? Then I'm going to, I guess, subtract the top one from this one, right? Which is going to lead to 0, -1, and -2 here, right? So I can swap this back. I can multiply this by -1. Not that it matters, but I guess simplifies things a little bit, right? So we have basically we have 3 free variables, right? Is that what you call them in math? Free variables? I forgot about this stuff. Everything is called, and this process is called the Gaussian like elimination, right? Okay. We can also like make all of these zeros if we want. I'm not sure if there is like any. I mean, there might be. I don't know. Yeah, so basically we have these 3 variables. All of these. Wait, but we cannot have negative values, right? Is another thing. We cannot have negative values. We can, because we cannot press a button negative amount of times. That would make no sense, right? So it's not just solving this, but also solving this where every variable is positive, and we will try to minimize the and we try to minimize the this sum of the variables. Isn't this like the We shouldn't be solving this here, right? Isn't this called linear? Like linear programming, right? Shouldn't we be using this simplex algorithm here? Because like, so we have some limitations, right? Like our limitations are that each variable is more than 0, right? And then we also know that like all of these, so we have these equations, right? But that's not all that we have. The other things that we have is like that every variable is more than 0 or equal, right? B is more than or equal than 0 and stuff. So we have these equations, and we also try to minimize a plus b plus all of these, right? That's what we try to do here in this problem. So we're trying to find the optimal. We have a system of linear inequalities, which defines a polytype, a polytop, right? So like an n-dimensional like polygon basically is what we have. But I mean, in this case, our polygon is really easy, right? It's just like everything is more than 0. Yeah. But we also have the equations. But the equations mean, but the equations is just equal to two inequalities, where this is more than equal to 0 and less than equal to, more than or equal to 7 and less than equal to 7 at the same time. Right? Like I'm just saying that, so we're trying to find like some minimum function here, right? So we need to like traverse along the edges of the figure that we get from these equations, kind of, right? Isn't that what simplex method is about? I don't know. I never actually did that thing. Also, here is another possibility. There might be something in the input which makes this a lot easier, actually. Like similarly to yesterday, when we had a circle, right, being our shape, maybe this time is something else. Yeah, simplex algorithm is just walking along the edges of the polytop to the extreme points with greater and greater values. It's like similar to like the gradient, right? But you always just walk along the edges, if that makes sense, right? Because your like n-dimensional polygon is always going to be convex. If you all have this inequalities, right? Because every inequality is basically cutting your space in half, right? So in case of 3D, each of these inequalities is the half space. In 2D, this is a half plane. And this is just like a single line, I guess. Yeah, like I mean, imagine the two-dimensional example here, right? Imagine the two-dimensional, like when we have just two variables, we just have two lights, right? If we just have two lights, then basically we say that the amount, no, not two lights. The one that we care about is that we have two buttons. We have two buttons. We have button A and we have button B, right? So A is the amount of times that we press like button A, and B is the amount of times we press button B, right? So obviously this should be all both non-negatives, right? So we are trying to find our solution in the top right quadrant of the space right here. And then we also say that something like A plus B is equal to some number, right? Which is basically just a line, right? And now we want to find the minimum, right? So so we have this like infinite like all of the like our potential solution lies on this line in this case, right? But we want to find the point with like a certain minimum, right? So if we were at this point, then we need to basically, I mean, in 2D this is too simple, I guess. But yeah, you just go towards the where the minimum is along the edge, which in this case there is only a single one. But yeah, too simplified in 2D, I guess. All right, but you are also saying that we can like solve this and then just do the brute force, like what are these free variables, right? Because probably the numbers are really small. A plus B plus C line, A plus B equals C line would form a triangle, but you never have that. You never have that. You only have do you does simplex algorithm even support that? I'm not sure. I mean, A plus B plus equals C is basically A plus B minus C equals 0. It does not form a triangle. It is a three-dimensional space now. You have A, B, C. You have three variables. It's now a three-dimensional space, and it's not a triangle. Well, I mean, it is a triangle in 3D space. Yes. Okay, that's what you mean, right? Because the equation itself, A plus B equals C, is just a plane in 3D, but then we cut that with like three semi things, so it's like a triangle. Yeah. So you start at any point and then like follow the edge, which leads you to the smaller number, right? But yeah, probably like in this problem you can actually like iterate over the like what is the value of these free variables, because probably the amount of times you press every button is really small, right? Because if we look at the input day10 input txt, right? Like the amount of times we press every button will never be more than any of these numbers, right? And all of these numbers, like I see 128 here, for example, right? This is pretty big, sure. But we can like, we can brute force this, right? If we have like just two free variables, then it's just like we will need to do 100 iterations, right? If we have three free variables, this would be like 10,000 iterations. So it's like it kind of like depends on these things. There's some with free variables, yeah. So like it really depends on the input here, how many free variables you have, right? And how big are these numbers. But they probably give you small enough numbers so you don't actually do the simplex method, because this will be even like more difficult, like because not everyone knows how to do the Gaussian like elimination too, right? That like doing the Gaussian elimination is already difficult enough, I suppose, right? Gaussian is easy. I mean, I agree. I think it's easy, but not everyone like knows about it, right? I think it's easy. Yes. But linear algebra was like my favorite thing. That like one of the only things that I actually paid attention to a little bit. Uh, Okay, but Gaussian elimination is actually supposed to wait, hold on. I was just gifted a sub in Bad Cops channel.
But it yeah, it makes a big grid of all the letters. And then it just runs a little simulation on them after it's got that, and it just keeps rendering. Yeah, it's fun. Is this one gonna take like infinity time now? What did I just make this number come out to?
Let's go. We keep solving this.
I just made this to the ×3 to the.
I mean, isn't our like how many variables do we have? It seems like we don't have a lot of variables, and Gaussian is going to be just the
resolve. To be honest, that's 27 times longer than it was, and it was already
like, I feel like it's actually going to run a lot faster than the part 1 because we don't like do the BFS here, right? BFS gives me 1,000 things. And you know what? Let's just check how many do we have of the variables in each of the machines, right? We're stealing code from Badcop? No, Badcop's code is Badcop is still solving the thing, so we'll see. Maybe we are racing Badcop now. Maybe I'm going to solve it before Badcop now. Like, what I'm saying is let's print the amount of things, right? So I want to know the maximum amount of lights and the maximum amount of variables, right? Okay. So this over here is going to be part 1. Right. And if part 2, then we do something else. Maximum number of buttons. Maximum buttons is 0, and maximum no shot, you solve it before me. What do you mean no chance? Hold on, why are you watching at my stream? Someone gifted me a sub in your channel. Thank you, whoever that was. You're watching at my stream. Someone gifted me a sub in your. Is your program still running? My my part 1 was running for 4 minutes.
in a few hours. Mine will be done.
In a few hours, mine will be done running. All right. I feel like part 2 though is supposed to be faster than part 1, but maybe I don't know. We'll see. Maybe I'm wrong about something. Your part 1 ran in 5 seconds. Okay. Yeah, my language is a little bit slower than Bash at the moment. It's okay though. Hello, Gian Calatito. We are trying to solve Advent of Code. Day 10, part 2. So I just wonder how many buttons we have and how many max, like, joltages or whatever, right? So over here I want... Let's also have the function maximum, AB. If A is more than B, then A else B. Yeah, so everyone knows a C++ programmer has joined the chat, so please keep the C++ lender down. All right. Okay, we'll try to do that. Although, I mean, do we actually trash talk C++ a lot here? I don't think we do that. No. Usually I talk shit about the language that I actually use, which is OCaml, right? I don't really say anything about C++ usually. The hard part is the part where you brute force all the options for the three variables and find the one that works. Oh yeah, this is the hard part. So that is the part that is made easy by doing the simplex method though, right? Because that's where you no longer the brute force, right? So maybe I will actually write the simplex here for the first time in my life. Okay, max buttons is maximum max buttons and machine buttons list length. We've definitely done that before. Maximum voltages is maximum max voltages list length machine voltages. And then I want to debug print this, right? dbg print max buttons and max voltages. Starting BFS. I need part 2 here, right? I'm still like just reading this is really slow, right? So yeah, whatever. Okay, maximum buttons is 13 and maximum voltages is 10, which means that we have 3 variables if this is the maximum at the same time, right? So we have 13 variables, 10 equations basically, right? And Gaussian elimination, the complexity is just the amount of equations squared times the amount of variables, right? So it's basically like 1,000, which is supposed to be like the same as this BFS, but I'm no longer going to be using the huge trips, I suppose. I will still be using trips though for lists, so yeah. So it's like it's actually about the same complexity to solve the thing, I guess. All right. Anyway, let's see. Let's do over here solve answer plus equal solve part 1 machine. I'm just going to extract this to the thing, and then over here answer plus equal solve part 2 machine, right? So solve part 1 machine is this machine answer. Solve part 2 machine. Okay, let's just create the matrix, right? Sure. Sure. Let's just say matrix is what do I do here? We have rows. I feel like I will just do like rows, which is a list of integers, right? We just use int32. That's probably going to be good enough here, right? Wait. Like we also need to solve this in like like aren't we going to have divisions sometimes? And we will need to check if the division, like the division sometimes may have the remainder. And what do I do in that case? Do I solve the equations here with floats? And then like do something about that. I don't know. Or is it always going to be like it's not guaranteed that we can always do the division, right? It's not guaranteed. So what do we do about that? I don't know. Let's just see. We have matrix create is nm. This returns matrix, which is rows is list create for in 0 to n. We do row is list create for 0 to m, list pushback row 0, right? And then we do list pushback rows row, and we just return rows, right? Okay, then we want to say at mode, right, which is going to be matrix I and j. This is going to return a reference to an int, which is going to be a list at a rows I at j, right? Okay, at I j is at not aij dereferenced. What else do we want? I want to like swap the rows or whatever, right? So I need to like first, let's do this. Matrix is matrix create. So what is the amount of rows here? It's going to be machine voltages length, right? And the amount of columns is going to be length of machine buttons plus 1, right? That's what we want. That's our matrix. So now we need to do the elimination. First, we need to find the yeah. We just need to find for 4. How do you write this thing? We just go for let's just do loop. Let's just do loop, right? We start at 0 0, right? We start at 0 0. We start at 0 0. Formatting failed. Interesting. Oh, because that makes sense, I guess. So ij is 0 0. So I want to find in the matrix like lower than row I, including row I, in the column J, if there is any non-zeros, right? So I want to find the non-zero row, right? Non-zero row is going to be -1, right? But then we do 4 row in I to n. Let's call this n, right? And let's call this m. So for row in I to n, ha 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 ha, you lose. Did you think? Did you solve it? Hold on. Where is bad cop here? Where is bad cop? Oh, bad cop. I don't see you, bad cop. You're somewhere at the bottom. Hold on. Oh wait, no, you solved it. I found you. Oh shit. All right. It's okay. You had you started like 12 hours earlier than I did though. So that's not really fair, okay? That's not fair. You give me 12 hours to finish? Okay. You think I will not be able to do that? Because my language is that slow? Slower than Bash? Yes? Okay, we'll see about that. I actually had to revert my language to like not the last version, because last version has the performance which is even worse, like 100 times worse, because like I did something. Panic to do. This is just so that I don't have the type checking issue, which I have otherwise, because this function is supposed to return integer, and if I don't have the panic here, it will return nothing. And like now that you are looking, it's not even showing me the error message here. My LSP. You broke my LSP, bad cop. Why would you do that? There's some problem. It's because this is not compiled. Row. I have an actual bug right now. Oh, wait, I remember now. I cannot have modules inside here. I need to make this outside. There we go. List length. So over here, I'm trying to find the non-zero row, right? So we go for row in the 1, 2, and do if matrix at a row j is not equal to 0, then non-zero row is row, right? I'm actually wondering here what is going to happen if I try to swap this thing. You know, like if I have if I have variable x and y, which is like 1 and 2, we can swap them like right now by doing like xy is y and x. We can do that, right? But what happens if I say xx is xx? I mean, I guess it's going to work still, right? So because I'm going to swap row with the row number I here, right? Matrix swap matrix row I and matrix row J. I want to swap these things. How about that? So let's implement row this is just going to say list at a rows I, right? Okay, and swap is T A and B is just going to be AB is BA. Matrix row this and matrix row that. There you go. So I'm just swapping these two rows, right? So now the row now and at ij we have the non-zero, but we only do that if non-zero row is equal to -1, then I'm just going to continue, but I'm going to say first that j plus equal 1, right? Over here in the end we will say I plus equal 1 and j plus equal 1, right? So I guess this loop is actually for j in 0 to well, I mean we break from the loop if I is more than or equal than n or j is more than or equal than m, right? Then we break. That's how we do it here. Okay. So now at ij we have the non-zero stuff, and then we need to basically zero all of the rows below us, right? Okay. Yeah. So let's say that row is matrix row AI, and I'm going to swap the row with this one, with the other one. But then I'm going to say that for lower row in I plus 1 to n, right? We want to zero those. So we say that the row here is matrix row A lower, and then so like everything to the left is already 0, so we can like at least simplify that, you know? We can at least simplify that. So we can do for k in j to m. We say that lower debugging STL is a nightmare though. So you asked people not to be rough on C++. So since people agreed to that, you decided to start yourself. Let's see. Okay. Lower. We should say that list at lower k. So this is the cell, right? I want to say that cell needs to be minus equal. Well, first of all, I need to find the multiplier, right? So the multiplier is lower at j, right? Is lower at j divided by my current row at j, right? So this over here might not necessarily divide, is the only issue, right? So let's do this. If list at lower j percent list low at row j is not equal to 0, then panic. What do we do? I don't know, right? We'll need to figure that out. But then over here we say cell minus equal. Well, I mean, I only need that once anyway, right? We'll do that. This is going to be minus equal list at row j multiplied by multiplier, not j, k multiplied the reference multiply by multiplier, right? Let's see what's going to happen here. Not equal. Not equal. Where am I using not equal? Matrix at. Matrix at returns the thing. The integer. And this is an integer. This should return Boolean. What's the problem? I'll initialize an expression. This one. Oh, list at lower. Yeah, because these things must be dereferenced, right? So we have panic to do. Wait, so this actually did not happen. I just have a panic to do. Okay, but that's okay. Let's just say 0 here for now. Right? Let's run this for the actual input. This is actually pretty fast, I would say. This is just solving the Gaussian elimination here, right? This is a good speed. If this is working though, and it seems as it's not panicking, so like, but is it actually guaranteed that it's also always going to be divisible, or is that because of like my or is that just because of my input here? Because like this can be any number, right? It's not necessarily divisible. I feel like it's easy to create the test case where this is not dividing, but they are just somehow not. Let me just though print the matrix. Let me just print the matrix. Matrix, let's say print, print, right? Matrix. I'm just going to say list iterate. No, not yeah, sure. List iterate. A rows. I need to iterate here, saying row. S is empty list for. Now I'm going to do list iterate row x into s plus equal space plus 2 string x. Then we say print s. That's a different print though. I need to do stdio print then, right? This is wants to be a reference. Type shape list. This is not unit. List iterate. List. But what is row here? List of integers. Row is list of integers. Maybe I need parentheses here, probably, right? Because of yeah, because plus equal cannot just be on the right side. Maybe I should change the priorities here. I don't know. So yeah, let's just print the matrix here, right? Print matrix. Print a. It's print after Gauss. And then I want to kind of like print before Gauss. Wait, hold on. I'm doing an empty matrix. I'm just stupid. Hold on. I'm okay. Of course, this doesn't because my that makes sense. I'm doing Gauss elimination on the matrix which is 0. And by the way, I need part 2, right? Yeah, there we go. My matrices are 0. That makes sense. What do? I need to set up the matrix here. Let's maybe extract this to matrix. Gauss elimination A. Let's do a function size here. It's just going to be it's going to be list length a rows and list length list at a rows 0, right? Something like that. Yeah, I don't do reference to A here because we already have a reference. It actually is on optimization right now. Let's maybe then do the printing in the Gauss itself. Right? Before Gauss and after Gauss. Like that, right? So right now it's like all zeros, right? But what we need to do is we need to do for every button, right? List iter I. Do we have iter I even in the lists? No, we only have this for the things. Okay, machine dot buttons, right? We don't go for every button. Let's do that separate, right? Button index is 0. Over here we have button. But button is already right now in like the bit field thing, so I need to like unpack it here. Okay, fine, I'll unpack it. It's okay. It's okay, right? It's probably okay. N is machine voltages. Yeah. So we just say that for in this in 0 to n, right? We do if std op bit end button and 1 is not equal to 0, then it means that this button is affecting is affecting the light number j, right? So I need to say over here, I need to say that matrix at mut, we have the matrix at j, and at j and what? And j and I, which is the button itself. ji, sure, ji instead of ij, whatever. Plus equal 1, right? Yeah, and then I also need to say that matrix at, this is for all of the for I in 0 to n, I is 0, we do iterate machine voltages x into plus equal 1 matrix at mut I m minus 1, I guess, is going to be equal to, not plus equal, that's faster, right? And over here this is going to be equal to x, so this should be the proper matrices, right? Let's see. So now I'm panicking, right? Because it's that before Gauss, I still have like a lot of zeros here, which means that it's not correct, right? Oh yeah, because beat end is not correct. Like after that, I also need to say that button is std op bit shift right button 1, right? Like this. Okay, is this the correct matrix here? So for the 10 for this example, we say 3 is equal to, this is number 0. Number 0 is in the two last buttons, right? There you go. So the two last buttons combined give us 3, right? So this is the correct matrix. And then we just have the wait, we have exception division by 0 actually. Where am I dividing by 0? Oh, because this is,
my sprinkler goes like this and comes back like
nice. I don't have a sprinkler myself. What do you use it for? So I'm dividing by 0 over here, I'm assuming, right? I mean, I can see where solve part 2. Gaussian elimination, right? My stack trace over here, an expression. I mean this one, right?
boing 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 boing. Error. System malfunction. Rebooting.
Hold on, why am I dividing by 0 here? So like list at row j, list at row j. Oh, yes, I only need to do that if it is not equal to 0, right? Yeah. And say that if, let's say over here, this is going to be At row.
Bird drip drip.
Wait, what? No. At row is this. And this over here is at lower. Is that, right? This can happen just once here. As an optimization, I guess. So we have a row at J. It's supposed to be non-zero because I have found it, right? Solburn, hi. What was the resolution of that remounted as read-only? I just rebooted and it all worked. I have no idea what happened there though. Maybe I should have looked at the system logs after I rebooted. But I don't know. It seems like just the disk was for some reason just didn't exist until I rebooted. You know? At row. VG print at row. At row is 0. Which makes no sense because I have, so like this, because this is supposed to be in the non wait, hold on. Matrix row AJ. This is not correct. This is not J. This must be non-zero row. Non-zero row. I found the bug. Okay. It is still 0 though. Fine. Let's do matrix print. Let's do dbg print. IJ non-zero row, right? And let's do matrix print A. So I0, this is 0. Non-zero row is 3, which is correct, right? So this must be the first row now. And I swapped this row at I with a row at non-zero. So this is like my swap function doesn't work. Is my swap function not working? AB is BA. Oh, wait, this is not working. Hold on. This is indeed not working. You know why? Because this is changing these variables itself. I mean, I should have in the language so that you cannot mutate the variable that is not declared as mutable, right? This should be like a mutable reference and shit. So this must be dereferenced. We dereference these things, and we do swapping then. There we go. Yeah, my swap was incorrect. Okay, nice. Nice. So after Gauss, as you can see, this seems like the correct thing, right? So we have three variables here, three variables here, and everything. Yeah. Okay. Let's do before. Let's do if verbose, right, and stuff. That verbose is false, so I can like comment instead of commenting it out. Let's see over here if verbose. Ooh, okay. This over here is just unnecessarily at all. And this is what is these numbers? At row. Okay, there we go. So let's see for input txt how fast am I doing this. But it is panicking. It actually is panicking. It panicked on the first one. No. Yeah, it panicked on the first one. Yeah. The question marks. Question marks means that I cannot do the division. So what do you do about this in this problem? Do you actually solve this with floating point numbers? Do we solve this in floating points? Do we solve these in floating points? What are the other alternatives? The other alternatives that we can do is we can have a prime number. We can have a prime number which is bigger than the answer. And the answer cannot be bigger than the amount of than the biggest joltage, right? Okay, so what is a good prime number to select? What is my maximum joltage again? I want like maximum joltage, literally, right? Maximum joltage. So I want to iterate machine joltages. Machine joltages. X. Max joltage is maximum max joltage and X, right? And I want to print that thing. Solve part 2. Just return 0 here. I just want to know what is the biggest thing. I mean, we can also like maybe we should generate the prime numbers. Maybe we should generate the prime numbers. So the reason for the prime numbers is because we can do our operations using we are basically going to calculate the answer modulus prime number, right? We need a function for prime number s in O1. Yeah, so like instead of division, we basically are going to, so instead of working in like in the range of integers, which is all the integers, we're just going to work in the what's it called, like a ring from 0 to the prime number. Which and prime number gives us the option to do the inverse, which is division, right? So we define division in that thing. The maximum is 300. So I just need a prime number that's bigger than 300 here, right? But we say basically that like. What is the result of A divided by B, right? It's a C where C times B is equal to A, right? So, and we are always calculating this thing, module prime number, right? You wonder if that trick actually works? I'm pretty sure it works. So, yeah. Did you solve your advent of code using just floats? Actually, like floats technically might be like faster in my case because of the interpreter, because like just calling the extra operation has a lot of overhead right now in the interpreter. But it's supposed to work, yeah. But we would need to like check that the answer is correct without like after we find the answer, because basically negative numbers become positive numbers, right? So we need to like check. Because we don't have negative numbers anymore in the string. I mean, let's just do floats maybe for now, and like, but that's an idea to keep in mind. Maybe if I have some problems with floats, like what do I do? Like I will need to like round the floats too, then, right? Convert those to integers. I don't even do that right now. I cannot even like convert the float back to an integer currently. Maybe I just do that trick immediately then. So what we want basically is to, when we do this, we do this still in integers. But we just always divide here, right? So, but instead of doing the division like this, we instead say div this, you know, and instead of doing multiplication like star, and we don't do minus equal, we don't do that, no. Instead we say that at lower is sub. Let's do like mod dot sub at lower, and mod mul at row mul, like this, you know, is what I want. Am I not having the colon? There is a syntax issue. Yeah, we do this sub like that. So we do mod.div. So I need to not be doing the normal math operations here in my matrix. So we have this module. So basically, we will be working in a ring. If I remember correctly, that's called a ring, right? With ends from 0 to p. P is prime. This lets us define int division. With ints, let's just say modulo p, I guess. That's the correct thing to say. Yeah, so let's just say, what is p? P is a prime number more than 300. Prime numbers. Prime numbers, let's see, 313, right? It's probably good enough. We have 303, so like 313 will be more than enough here. Okay, so what do? I need to have the function sub, right? A, B. This is going to be this extension for strict typing. Well, I mean, for me, the main purpose is the screen shaking, not streaks. I disabled the streaks, but the streaks are also in the same extension, I guess. It's called power mode. Hi. Yeah, we just say a minus b, but we cannot just say a minus b, right? We say a minus b. This is my result, right? But if c is less than 0, then c plus equal then c plus p, I guess, right? If c is more than or equal than 0, then c else c plus p, you know? Like that. Because can I just do c plus p here though? Yeah, that should work. So basically, if it's negative, because these numbers, they were always from 0 to p, right? If it becomes negative, it's just like adding a single p will be enough. We don't need to do a while here or whatever. Okay, when we do add ab, we'll say that c is a plus b. If c is less than p, then c, else c minus p. So like similar stuff. But for the whiles, we will actually need to do the module operation, right? So multiply ab is going to be a times b percent p. That's all. And then division. The division is the interesting one, right? If we have a and b, we need to basically multiply a by inverse of b, right? I guess we need to multiply a by the inverse of b. And what is the inverse? Inverse is like 1 divided by b, right? So what is inverse? How do we do inverse though? Wait, hold on. This requires the GCD, I think, right? If I remember correctly. We need to say like x times y is equal to 1, right? But x times 1 mod p is equal to 1, right? That's the thing. So how do we do this? It means that x times y must be equal to k times p plus 1, where k is some number, right? So we need to find any number y which satisfies this thing, right? So we have actually two. Wait, how do you do that? I forgot my math. Let me think, maybe I will remember it. I can look it up though. If we move the k times p in the left side of this equation, right, we will get something like this: minus kp is equal to 1, right? K is any number, so it might as well be a plus here. It doesn't matter. So we know x, we know p, right? We know x and we know p, and we need to like figure out what these numbers are. Basically, you do that by doing what? So the reason we choose the prime number here is because GCD of x and p. Well, x can be 0 though, right? But the thing is that the GCD is always going to be equal to 1, right? And so while calculating the GCD, we can represent the GCD itself by doing this, right? Whatever. So we can find our y and k this way. correct. Because because we know that the prime, the GCD will always be equal to 1. So we cannot do it by like by doing that here. Yeah. Okay. Hold on. So let me remind myself. How do we do a GCD? How do we do a GCD? If we have A and B, how do we do a GCD? So this is going to return basically. So this is supposed to return the multiplier for A, the multiplier for A, the multiplier for A. Let's call this I don't know, MA. The multiplier for B, the multiplier for B, and the GCD itself, I guess, right? Which is just an integer like this, right? So we say that if we start by doing what? If A is 0, is that what we stop at zeros, right? Then we return B. MA is 0, MB is 1, right? Because if we multiply B by 1 and add A multiplied by 0, then we are going to get B, right? And that's our GCD. Return. Let's not do return. Else, if B is equal to 0, then it's the same thing, right? We say A, MA is 1, MB is 2. Otherwise, so these are both non-zero numbers. So what I need to do is what? I want to. So are you done yet, or should I raid you? I don't know. If you want to, there's probably other people. I'm not done yet though. I'm doing something like. I'm doing something. Did you solve your equations with floating point numbers? I'm trying to do the integer like solution without using floats. You did not do floating point? How do you like do you do the same trick that I'm doing here, where you calculate module prime number? Well, I guess what we okay, wait, hold on. I know like a different solution here, I guess. Collaborate. Okay, how do I do that? Allow. I don't think I think I don't hear you. Wait, what did you rate me? I mean, thank you, but did you just try to do the collaboration thing? I don't hear you at all, though. Why don't I hear you? Do you hear me? Like, I see the thing. I see that you are like talking here, but then it doesn't do the audio. It's because autoplay. I need to allow. Wait, I just heard something. Is this thing just buggy? Thank you for joining. Okay, I give up. All right. Did you hear me though? You want me to see my bash code for this? I mean, sure, I can look it up. But advent of code 25 part 2 very easy. GG, go next. So So you have Gauss, Wikipedia row echelon form algorithm. Row echelon form algorithm. What even is that? Why don't you even put the link to this thing? This is not Wikipedia. Oh, there we go. Oh, this is the row elimination, the Gaussian elimination. I guess. Sure. Yeah, but like, don't you divide here? You have denominator. We can't safely divide, so we scale the whole row up to compensate. Yeah. Makes sense. Makes sense. Yeah, I can do that. Yeah, instead of doing the module stuff. Yeah, I just thought about it as you were raiding. I am not stealing your solution, okay? I just came up with the same thing myself, okay? Am I doing the Wikipedia? I don't open the Wikipedia. I've done this a couple times, the Gaussian stuff. But I mean, normally when we can do the floats, we work with prime numbers. But I mean, like in this case specifically, it's I guess fine. But like it depends on the input, right? If we work with modulo some prime number, then we can actually safely divide. Is the thing, and then you don't like scale like exponentially or whatever potentially. Just on this cable is not divisible. Yeah, but it only works because of the input that they are giving you, right? Say Shumara, hello. You could do GCD after each operation to reduce it. Yeah, or we can calculate everything module number. Okay, but yeah, I agree. That's too much work. But I was already writing the GCD though. Whatever. Let's remove this. Maybe later. Whatever. Yeah. Okay, fine. So I don't do the division here. If at lower percent at row is not equal to 0, then let's steal the comment from Badcop though. We can't safely satisfy. So we like scale up the row to compensate. Sure. Lower. What div at lower? Wait, what is at lower? Matrix row. Did I just delete something? Too late, I deleted it now. Let's just do matrix at no, not matrix at, list at lower j right. If this is not 0, then we multiply, and then multiplier is this divided by that. So now it can be divided, right? Sure. So over here we just do list iterate lower x multiply by at row, right? So we just do stupidly like this. Okay, yeah, sure, let's do that. At lower minus equal at row times okay. Can I do the verbose thing again? Room. Let's just see. Let's see what I'm returning 0 right now. And solve part 2. Okay, so it looks like my Gaussian stuff is working. Okay. Okay, we are almost there, right? This stuff works. So now we just need to brute force figure out what the free variables are, or do the simplex method. Did anyone actually do the simplex method who was solving this? So we actually, yeah, hold on. We actually have 3. Let's do that. I want to like figure out the amount of free variables and the maximum joltage, I guess, right? Do verbose false. Let's do verbose like in day 9 maybe. That's not how I did it. No, whatever. Let's do false. Boom, 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 boom. I want to know how many free variables do I have. So we do Gauss elimination, right? We do Gauss elimination. So how do I know the free variables? How do I know the free variables? We we go bottom to top. Well, I mean, over here when I'm skipping, this is the free variable. Over here when the non-zero row is this, that's when I'm skipping, right? And every one at the end also is the free variable, right? Yeah. Yo, T2SD with another rage. Nah. Hello, hello, hello. T2. How are you doing? And welcome everyone. We're doing the Advent of Code Day 10 part 2, which is actually I mean, I wouldn't say it's difficult, but I'm doing it in my own language, which is having a really slow interpreter. So we'll see how slow this runs. So we're doing Gaussian elimination as part of the solution here. And next, what I want is to calculate the amount of free variables, and maybe like just a list of free variables. Yeah, how about I just do the list of free variables? That makes sense, right? And then the other ones can be computed using these. Right? Should this return free variables? Just a list like that. So free variables is list create over here. Since j plus equal 1, since non-zero row is -1, I will say that free pushback free number j, I guess, right? Number j. But only if j is strictly +1 is less than m, I guess. Because the last column is not the variable column. Right? And then over here we do for j in j times m minus to m minus 1. We also do the same, right? List push back of free j. And then I want to do print three variables is this, which is going to be trip to string free inner x to string x, right? Let's start by doing this in the example. So we have three variables 3 and 5, and then we have three variables 2, variable 3, right? Sure. And also I want to print the max joltage here too, I guess. Max, I mean, yeah, yeah. Maximum joltage is 0. List iterate machine joltages x max joltage is max voltage X. And print max voltage is to string max voltage. Right, let's do this. So yeah, just so that we understand. Just so that we understand. Max voltage ET1, we have two variables. Over here 150, but we have 0 free variables, which is good, right? So I don't need to do any iteration at all. 203 variables, is that the biggest one? 203 variables is a lot, actually. Like, yeah, this is going to be really slow if I try every, like, if I try it all. But also, like, it depends. Like, this variable might also be limited by like something else, you know. Maybe we can do some like 255 and 2 of them. That's fine. We just need to find the 3 ones. Only 90s. Hold on. Let free be that. I want to. I can do that too, by the way, right? Or can I? No, I cannot. I want to say that print free vars times max. 3 times max, I guess, right? Is going to be equal to string max voltage times the list length of free, right? Like this. Voltage. Because that's the important part, right? That's the important part. And I want to find the maximum one of these. Yeah. So like maximum. Oh, wait, it's not this. It's not. No. It should be like max to the power of 3 variables, right? Yeah. Let's do like power max voltage to the power of this. Let's do the power. Let max maximum brute, I guess we are going to call it that. And so this is the amount of brute force that I need to do. So brute is this, or like I guess like combinations or whatever. right? Let's do the power. Power is xn. I'm just going to do the stupid stuff, right? Result is 1 and then 4 in 0 to n. We say result time equal x, return result. Then I want to say that max combinations max combinations is maximum max combinations and combinations, right? Like this, and then I can debug print this in the end. All right, let's go. Okay, this is going to like run for a little bit, I suppose. But over here, max combination is 6,000. This over here, right? This is probably the biggest number. I'm assuming. Which is 10 million, which is a lot. Right? Hello, Boolean. $10 million. This over here. Max times 3, you did that too? Yeah. I'm actually wondering if I should just do the simplex method, but I never did the simplex method before, is the problem. But that one's supposed to like make this like a constant time probably like solution after Gaussian elimination, I think. Actually, you didn't do that, to be honest, and it works out. Well, I mean, also, like, we can do a lot. Like, for example, it's not exactly max to the power of 3, right? Because, like the sum of all the variables should not be more than the maximum, right? Which means that we can at least divide this number by 6. At least. At least. Hello, it's Lysek. Hi. So at least by 6, and then we can also probably do some other things to make it be a smaller amount of things to brute force. They tend took you quite a bit too. Did you do the simplex method? Did anyone do simplex method? I'm just wondering if anyone did that, or did everyone just do the brute force after the Gaussian elimination? Liquid Katie was talking about it, but it doesn't yet. You didn't brute force either. Well, I mean, not brute force like the entire solution. You do Gaussian elimination and you have 3 variables after that. Well, I mean, hold on. Where I'm talking simplex method, but our like our restrictions are actually very, very simple. You know, our restrictions are very simple. Specifically, every variable is more than or equal than 0, right? Every variable is more than or equal than 0, which means that at least one of these variables must be 0, right? And I ran out of memory, by the way. Wait, I ran out of 10 gigs of RAM. I have a memory leak in my program. So, I'm just isn't one of these free variables supposed to be 0? If we have, or is that not necessarily true? Is that not necessarily true? Not really. Valgrind time? Yeah. I already fixed one memory leak earlier. Not today, but I had a memory leak before. I mean, I can just start working on the brute force, or we can think a little bit more. The math seems wrong. What math? What math seems wrong? This one over here? I know what's wrong here. Max to the power of 3 part, I guess. Then again, I might have done it a bit overkill. Max to the power of 3 is also overkill. Yeah, it is overkill. It is overkill because, like I said, at least like the sum of all the things should be less than maximum, and also like not every joltage is the maximum joltage, right? So there's a lot that we can remove from the brute forcing here. Yours doing maximum divide by 3 to the power of 3. X to the power of 3 minus 1. No, that's not right. I'm just trying, like, before I implement the brute force, I'm just thinking. Step back from brute forcing, that's not how Advent of Code should work? No, I mean, this is the proper solution. If you do it in a proper language, like C++, brute forcing, you only brute force this amount, right? Which is less than a couple millions, which is supposed to run less than a second. That is totally fine. That is the Advent of Code solution. I don't see why not. It's not brute forcing the entire thing. Not the entire thing is the brute force. Only the last part. After the Gaussian elimination. It basically is, though. So, I mean, I only see the simplex algorithm right now as the other thing that is not brute force. Sure. But once again, like, it's not like we shouldn't do the generic simplex, right? Because our constraints are very specific, right? We don't even have the, like, we have a bunch of n-dimensional planes which we intersect, right? Right? We just have a bunch of n-dimensional planes that we intersect. So we have, because we have only 3 variables, we are working in 3D. We have a 3-dimensional. We have like the tetrahedron is what we have. right? So we only need to go like along a single edge in the simplex method, I guess. Maybe like 2 edges at most. So like yeah, you modify the simplex algorithm a bit to get the correct response. Yeah, I'm just saying, like, the simplex method is too generic, right? Our thing is very specific, right? Like, the only inequalities is that every button press is more than 0 or equal. The other things are literal equalities. I mean, let's say that we have 3 variables, right? Let's say that we have 3 variables. So we have 3 variables, A, B, and C, right? But we have some... Well, I mean, wait, we don't necessarily have the equation, but I mean... Yeah, I don't know. Never mind. You're getting there. Yeah, but so you're basically saying the simplex, but a special case. We have 3 variables. We have 3 variables. Wait, the 3 variables, they are completely free, right? They are completely free. Which means that we just have like the cube there, right? Yeah, the only thing that we need to is to not let any other thing to be negative. No. It's weird. If Bash can do it without simplex, I think you're okay. Think about simplex by explaining to a 5-year-old helped me a lot. I never did a simplex method. I know what it is, like, in theory. Because I heard about it. I never implemented it. I cannot explain it. No. I can try thinking about it harder, but hold on. I mean, in simplex method, we start at point, right? We start at a point. We start at a point. I mean, let's say that we are fixing two, like, let's start with the simple stuff. Let's say that we only have a single free variable, right? If I only have a single free variable, then every other variable is some linear formula over this single free variable, right? So, and we need everything to be more than 0, right? So we have a bunch of equations, so we can solve and find, like, the minimum value so that every other variable is still more than 0, right? Because we just literally make like whatever, you know. We will just basically end up with having a segment where of what this free variable can be, right? So we don't need to iterate there. We can do just the Well, I mean, hold on. We still need to iterate because we're also trying to find the minimum, right? Which is weird. Like, but is the minimum always going to be at one of the ends? I guess. Yeah. It has to be in one of the ends. No, not always. Maybe you have to use the raccoon in the prompt. Why would it not be always at the edges? Because okay, no, it makes sense. Because like in this scenario, for example, one of three variables is the I don't know, let's say like x-axis, right? So the answer is not at one of the ends of the x-axis here, right? It's somewhere in the middle here, over there. Because yeah, makes sense. So I have a bunch of equations, and then I need to also minify the sum. Um, I don't know. I feel like it's easier to just do the brute force. I mean, I should probably like think about it more. But my goal here is not solving the advent of code. My goal is testing the language. So yeah. But it's going to run forever. How long did it run for you, Bad Cop? 40 minutes? In Bash? Want any more help? Yeah, sure, I don't care. You can give me help. But, yeah. 10 minutes to run? My day 9 was taking 20 minutes to run. So, yeah. Mod 2 linear algebra is what you used. This doesn't make sense though. You can hit the button more than once, right? Why would it be a mod 2 there? I was thinking of doing the linear algebra module some prime number, which is greater than the highest voltage, though. Mat2 is basically XOR, yes. So. What does it give me? You're overthinking it quite a bit. I'm not even thinking. I'm trying to understand what you mean. You're doing you're trying to make me to think XOR is helpful for part 1, but you didn't see how it's relevant for part 2. Yeah, I was using the the XORs in part 1, yes. How is it relevant for part 2? Maybe you are trying to tell me to solve the part 1? Is that what you're telling me? Do you think that I'm trying to solve part 1 right now? I'm not. I'm already solved part 1. Already solved part 1. Part 1 is like obvious, yeah. So, but why are you talking about the simplexes then? Then that makes no sense. Because like I don't know, how do you even think about that in part 1? Makes no sense. Well, I mean, I guess it's because like I guess it's because like in part 1 you basically have like the cube basically, right? Or whatever. That's all that you have, like an n-dimensional cube, and you just like maybe I don't know. Boolean channel. Looks cool, you see. I don't know. Let's follow them then. All right. But yeah. Are you sure that you did not do the brute force for part 2 then? After Gaussian elimination. The QTA was definitely ranting about simplexes for part 2 though. Okay. Okay, I guess there's like just 2 solutions, brute force and simplex. But simplex, I guess, can still be like more. You're actually right, I did brute force it. Okay, there we go, there we go. There we go. There you go. So we just spent 30 minutes thinking about how to not brute force and how to not do simplex. And I don't know, maybe there is some other solution, but I don't know. All right. Let's do brute force then. Let's do brute force. Okay. Do we just figure what the free variables are, and then we calculate the other variables, check that the other variables are in range, right? And that's it. You want to find the proper way? Well, I mean, simplex is the proper way, but yeah, like I said, I feel like there can be a specialized simplex algorithm, maybe, for this problem specifically. Right, so we go over the free variables, right? So yeah, let's say I need a recursive thing here, and I cannot do recursive thing here, by the way. Can I? Wait, hold on. Can I do a module here in general? Can I do let f be a function which calls f? Does that work? I guess it does. It's just I cannot do const here. Wait, I can. Wait, what wasn't working? Maybe like if I try something here, pbg print max combinations. Let's do this. Can I do that? Yeah, I guess that works. Okay. And to have like a better syntax for defining recursive functions, though, I guess. All right. So let's call this brute, and let's call this force. So with brute force, the variable I, right? So we start brute force at free variable number 0. Here. Type shape unit is not equal to that. Yes. Root.force is good code. Yeah. So I just need to... I have the max joltage, right? So let's just do this stupid stuff for now, right? For x... Well, I mean, so now we also need to like assign these variables, right? Okay. I see. Let's actually start at brute force list length of free variables, right? And then I say that if I is less than 0, that means that I have set all the variables. And otherwise, we need to figure out what this variable is, right? Okay. So we can I have a function that calculates every variable or something? How do you calculate them? I mean, it's easy, but okay. Let's see. Over here I will force I minus 1. But I will do that for x in 0 to max voltage plus 1, I guess. Right? So I need to assign variable I to be equal to x. Right? So I will actually have what variables actually are. Variables list create for 0 to m minus 1. This is my variables, right? List push back vars just 0. So over here, I'm just going to say list at vars not I, but list at free variables at I. This is my index of the actual variable, right? I dereference that and take the variable at that index, and that is going to be equal to x, right? Okay. And now if I is less than 0, then over here we just try to calculate all the other variables, right? Maybe this should give me like the maximum, you know. So we say maximum is max voltage, right? So we have I and maximum, you know. So I go to maximum plus 1 here, but over here I do this brute forcing, and I say that maximum is maximum minus x now, right? Like the other free variables. That's why we divide by 6. Is it by 6? I think it's by 6, right? Yeah. So I just need to check all the other variables, right? So we go for j in 0 to m minus 1 reversed, right? I guess let's put this to the top. So this is all the variables that we need to do, and we go from the right side because our matrix is like that shape or whatever. We go row is n minus 1 also, right? How do you write this code properly? So we have the matrix. I need to like find the first I need to like to see the non-free variables, right? And see the non-free variables and in which row are they located. I can just save this information when I'm doing the Gauss, I guess, you know, because my Gauss is returning my Gauss elimination. Why can't I go to definition here? Await compiled. Something is not compiled. Oh no. Nothing works now, right? There's something wrong over here because I cannot do the recursive function. I can only do the recursive function outside of the function. Which is not ideal. I need to like figure out why though. Oh. So the reason is because like I'm using something is wrong here. Okay, I need to restructure my code because of this bug in my language right now. Let's have a brute. Wait, this Must be a const anyway, right? So yeah, we just don't have access to these variables, so I cannot capture anymore. Which means that I mean, but I can at the same time say n is 0 and m is 0, and vars is list create or whatever, right? And free is list create, and I can like assign these variables from the outside, right? All this work just to make the language that looks like JavaScript. Does this look like JavaScript? Close enough. All right. So before doing the brute force, I will need to set the variables of the brute, right? N, M, vars, and free. Brute N is N. Brute M is M. Brute vars is vars. Brute what happened there? I didn't see something. Something just happened. Brute free is free. Right? I did that. Another scam website link. I see. You mean X? The Twitter is a scam website. Mine is very funny. Aside from SQL, these are pretty much the same languages. Yeah. I mean, well, I mean, pretty much. I mean, SQL is also not much different, I would say. Like, why are you saying that SQL is any different? Why is SQL any different? Well, I guess among these languages, the syntax is the most different, but I don't know. If it wasn't a scam website, you may have banned an innocent person. Bad cop. Alright. I don't know how to see the link though, because yeah, whatever. I'll work on my inventive code here. So I have brute forcing, right? Over here, I'm setting the variables, and now I need to like see the variable. I also need the matrix, right? Matrix is matrix create, I guess, 1 1, right? But I'm going to just say 0 0 here. I can 0 0. I can. Root A is A. Check. I guess check is what I'm going to say here. Check. It's a function. All right, so what do? Yeah, I need to like say free, and I want to say the not free. So fine, that's not free, not free. List create. I want to, yeah, I want to do that. I want the not free though to be reversed. How do I iterate reversely? I should be able to do that, right? Like Gauss should return free and not free. Not free should give me the the variable and in which like, you know, row and column. Yeah, how about that? Row and column. So column is the variable itself. Just to use the inference here. Free, non-free. Non-free is list create. And over here, since I used this one, right? I'm just gonna say that list push back. Non-free. We have row is I, and like variable itself, I guess, is J. Right? That's what we do. If J plus 1 is less than M, of course. Okay, so we have rows, the row and variable. Okay. Brute. Non-free is non-free. Non-free list create. Okay. So when we check, we just go over all of the non-free variables, right? So for we do list iterate. Wait, non-free, not free. List iterate. Non-free. Why did I call it non-free? Not free? Not. So I have a variable and row, right? Okay. So now I just need to calculate the value of this variable, right? I just need to calculate the value of this variable. Okay. And I just need to go from the right side, right? So I say for J in yeah, and just like say result is equal to matrix at row m minus 1, right? And then I go for J in var plus 1 until m minus 1, right? Rev, I don't need rev here. So I just say that result minus equal var, no, not var, minus equal list at, so we get the value of the variable J. We get the value of the variable J. We multiply that by a matrix. Let's just say over here that row is matrix row as an optimization. Which means that result is going to be instead like list at row m minus 1. The reference then. We just do list at row J. Right? We do that. And then I need to divide. Can it be not divisible? It can be, right? Yeah. It can also not be divisible here because I need to divide the result by by k, where k is what? K is list at row variable itself, right? And this is my variable itself, right? This is my variable itself. If result percent k is equal to 0, I guess we do with return here. So I just return from the checking here. Is not equal to 0, then we just return. Otherwise, we say that vars at var is equal to result divided by k, right? That's all. And now I know all the variables. I also like I just need to check that the variable is in range, right? Right, so I say that if result is less than 0, then also return. This is also bad. What else is bad? Anything else is bad? Anything else is bad? Let's also calculate the current like answer. So this is like I'm going to have the answer to be equal to 0, because I need to have the minimum answer, which means that it must not be 0. It must be what, like a billion, right? Let's do a big number here. So I'm going to calculate the current answer. The current answer is going to be all the free variables first. Would you believe I have the exact same thing in my code? Which code? Like, you mean like this? Or you mean like answer is 1 billion? I'm just going to iterate over all the free variables. I want to add to my current answer. Oh, wait. Hold on. Also, maximum that we are... no, really. Mind. But this maximum should never be more than the minimum, right? Because more than my answer, but it probably is whatever. But yeah, I'm just going to say that over here, something like current answer plus equal variables var, right? This is already known, and these are the new variables that I'm calculating here, right? Value. So value is this. What's the result? Oh, I just need to do, yeah, I just need to do here result divide by k, and then this is result. But if result is less than 0, should be checked earlier, maybe here. I could check it even earlier. If I kept all my non-free variables to have positive things in them. Probably doesn't matter though. So we set this variable, right? But I'm also going to say here that my current answer is going to be plus equal result, because this is the new variable that we calculated, right? But if at this point, if current answer becomes bigger than the actual answer, then we also return, because like it doesn't make sense. It doesn't make sense for us to continue doing anything here, right? If it's even equal also. So then after the end, when I calculated the answer here, I'm just going to say that answer is max answer and current answer then. Is that all? Is that all? This multiplication should be this thing should be dereferenced here. Type over here percent k because list at is actually also needs to be dereferenced. Okay. Part 2. Binding free doesn't have fields. What do you mean? Binding free doesn't have fields. Binding free doesn't have fields because this. Let's do it a let here and let's do this a let here. I think this should still work, right? Out of bounds. Out of bounds. Where do I have out of bounds? I have out of bounds. Where? This over here at free I. Because force is being called over here. Because I need to say list length -1, right? Because I start at the index at that index. There we go. Okay. Now the answer. Now the answer. Hold on. This answer is answer part 2, right? So we say over here if part 1, then that, otherwise we print answer part 2, and I guess I can rename this to answer part 1 too, right? Wait, no, that answer was answer for the machine. So this is still just the answer. This is not answer part 2. No, never mind. It's not correct because that answer is just the answer for the current machine. This is answer machine answer, right? Which I guess could go into the brute force. And I will need to like reset it or whatever. Start with 0, and then we say over here that brute machine answer is a billion. Read chat, maximum, not minimum. Why am I printing 0 though? Well, I mean, I'm returning 0 here, right? I need to return brute machine answer. Yeah, I'm trying to find the minimum, right? Over here, minimum. I don't have minimum. Hold on. Let's do minimum. Minimum is that. Right? Inference error over here. Solve part 2 in 32. Brute machine, because I don't need to do the semicolon here. The answer is 35. Is that correct answer for the example? 33. Why did I do 35? Why did I do 35? Let's debug here. dbg print answer is toString brute machine answer. It's close though. It's very close, right? 10, 12, and 13. 10, 12, and 11. Okay. You split pivot and free variables. Yes. I guess, yeah, that's the correct term, right? I call them non-free, not free, but these are called pivot variables, right? This is called pivot variables. Yeah, I do split them. Why is this red? Because this is still called not free. Leave it. 10, 12, and 13. Okay, why is it 13 then? Now I need to like figure out how are you minimizing the sum? By calculating the sum and saying that it's the minimum, right? Thank you for coming by, Boolin. How am I minimizing the sum? I'm just saying that machine answer, like this thing, right? We are calculating this by saying that that's minimum of the current answer, and current answer is the sum, right? It's the sum of variables. Maybe I'm not maybe I'm not brute forcing everything. Let's see, brute force, I max, right? So I just go x from 0 to max, including max, right? I set the variable to be equal to x, and then the new maximum is maximum minus x. Is that correct? What if I just keep with this at the maximum? There's no way though, right? 13 still. Like that's no, that's correct. Still a noob question, but as Twitch has a way of seeing what channels you've been watching and how much. Not really. You can. I'm not even sure how to properly like find the channels that I'm following because they're not even sorted lexicographically. You know, sometimes it's hard to find the person that I want to find. But yeah, there's the recap, I guess. You can request, report, and download. Can you actually sort your following the channels you're following by name, by the way? Anyone knows that? I can write a program that does that for me, I guess. Browser extension time. Do you guys not have that problem where you're trying to find a specific person and then like because the channels are not sorted, it's really difficult to do that? Maybe it's because I'm following like 1,000 channels. Use search bar. Yeah, I guess maybe search bar is what I should be using. Okay. So how do I find the bug? How do I find the bug? I need to like say what are the free variables that I tried counting, right? So let's say let's do this. Print try print. No, let's say over here, you know. This is value is this, and then we print print to string var equal to string value, right? Something like that. So what have I tried? I tried 0, 1. I mean, isn't this going to tell me anything? Wait, there's only a single free variable in the last example, right? There's only a single variable? Yeah, there's a single free variable here. That's right. So the only free variable is the last one, which is correct, right? So we try this being 0 and everything, and it being 11, and the answer is 13. What's the actual answer here for the last one? Is there example? 11. One way to do it is by pressing the first one is 5 times 5 once. 5 5 0 5 1, right? So it should be 1. So when 3 is equal to 1 over here, if this is 1, then so this variable does not exist, so this is equal to 5, which is correct, right? 5 times, yes. Then we say that so we say 1 minus 1, which is 0. So this one we do 0 times, correct? I guess I just didn't calculate this correctly. This sum or whatever. And then over here we do 10 minus 5, which is 5. This one is 0, so like this is literally 5. Yeah. It should have been 11 here. So I just did not calculate this correctly, the actual answer, right? Print current is toString current answer, right? I can also say what all of the other variables are here. Right? Yeah, sure, let's do that. Let's say over here. Variable is equal to toString result, I suppose. Print pivot. So we do the printing of the free variables and then the pivot variables, right? So when we say we try 3 is equal to 1, then number 0 is 10. It's because I'm trying to calculate this 0 first. I need to do it in the opposite order, right? I need to do my pivot variables in the reverse order. I said that, but I didn't do that, right? How do I do that though? Can I like reverse my pivot variables like once over here as a hack or whatever? Pivot variables. Can I do reverse? I can iterate reversely though. Let's do iter rev. Let's do iter list iter rev. Sure. List iter rev is for t. We have list which is a list of t's, and we have a function. Let's just make it be yeah whatever. Yeah, whatever. We have this, we have function. I'm just going to... This should be like for the trip, because that's how I'm doing my study collections trip. Here, right? Trip team. So I just match A with empty. We don't do anything. If it is a node where we have sure node, right? I can just say trip iter rev node, right? Go. Let's call it go. Right? Let's go. Oh, I cannot do that. Shit. Oh my god, I cannot do that. I feel like I need to do trip is module now. Iterate rev is iter rev. Node, right. Do that. F. node left, f, and then we also call function f with node value, right? That's what we want, and then move this eventually. Trip iter rev pivot dot inner, I guess, like so. Trip. Okay, is that going to work? 33. Nice, easy first try. Let's remove the logs. Remove the logs. I kind of want to like see the progress bar. Nah, never mind. I mean, yeah. I want to not limit its RAM, I guess, here, because I know it's going to run out of RAM already. A10 main KS part 2 input txt. Okay, please. This is right now trying to do 6,000 combinations and it's still running. This is just 6,000 combinations. It's been more than 5 seconds. It's been more than 10 seconds already. We are going to wait for eternity. Has anyone tried pasting the linear equations into the constraint solver? 6,000 takes that long, you're screwed. Can confirm. Okay. A little bit faster than Batcop's bash code? No, there's no way. Batcop's code is also that slow. It's literally just doing this first one still, right? 6,000. 6,000, it should be instant. Yeah, it should be instant. Okay, let's do a little bit of profiling then. Do a bit of profiling. Just profile advent of code day 10. Part 2 input txt. Let's see where my time is. Maybe stuck in a loop. Maybe. Is it compiler interpreter? I only have interpreter right now. Compiler is planned. But I have the interpreter, which is really slow right now. Because it's not intended to be used as an actual interpreter. It's intended to be used for compile time evaluation only. So it's like, and there it needs to do things that you normally don't need. It's still just red. Does perf record adds overhead? It only read machine 1. It didn't even do the Gaussian thing yet. Oh wait, it's because I'm in the main branch, right? Hold on a second. Can it stop working, please? It's like... Can it stop working, please? Thank you. I just wrote 2 gigabytes of perf data. Okay. You gave up and used CBC instead? What's CBC? Canadian Broadcasting Corporation. It's because right now over here I'm in the head, right? Master, let's check out this thing and then try profiling. Yes, because right now in my latest version, Oh wait, now it panics. Wait, why did it panic though? Makes no sense now. No native RNG. No native RNG. No native RNG. Why not? RNG. God. Native function RNG. It's here. Oh, it's because I need to build it first. Dune build. Right. There you go. Okay. 6,000. Let's see. Coin or CBC. It's just a solver, open source, mixed integer program solver, written in C++. CBC is intended to be used primarily as a global library. Linear programming. So you are doing like this to call into the simplex, which is already implemented or something? Or just to do the Gaussian elimination? I mean, the Gaussian elimination is fast. Which is actually, I mean, because this is really small metrics, right? It makes sense that my Gaussian elimination is fast. If that was slow, that would be really bad. Let me just see. I did 2 gigabytes. 2 gigabytes. I mean, 1 gigabyte of this thing. Can I even load it? Oh, I can. Okay, flame graph. Wait. But it's not because we terminate the recipe. Check IO CPU overload. What does this mean though? What does this even mean? Yo, ending with Ali. Hello there. Thanks for the raid. How are you guys doing? I'm trying right now to solve the advent of code A10 in my own programming language, and it's working slower than Badcop's bash solution. So I'm trying to like figure out what's wrong here. Yeah. And Badcop's solution was running for 10 minutes, and mine is going to literally run for eternity because of things. We have the programming language which is looking more like a language than Bash, I guess, but performance-wise, it's the opposite. How are you guys doing anyway? Welcome. Let's see. I feel like maybe like let's try profiling again. Let's just wait for a couple seconds, and then I will just do Control C here, so that it's going to write the report. Okay, can I just do perf report? 256 megabytes, okay. Inference check unite. Map add. ID compare. I have the map. I have the map somewhere where ID is the key, which is taking 40% of my runtime, and this is inference. But this feels really wrong. So what this profiling data tells me is that I have inference running at runtime instead of at compile time, which is not supposed to be happening at all. Well, I mean, technically, it's happening sometimes. But why is it happening? It's happening sometimes because Because I'm doing substitution of the variables, right? Because I did polymorphic things, polymorphic native functions. So when I go into my interpreter, common, over here, we have expression native. This. Wait, no, there is no substitution of the bindings happening here, right? Yeah, I'm just using the original type. I hope it doesn't turn out to be a bug in your language itself. I mean, it probably is. Like, at least like the memory leak that I have, the fact that I'm using 10 gigabytes of RAM to run the Advent of Code solution means that there is a bug for sure. It's because I'm not holding on to the references to the things in every like line of the input, right? So it's supposed to not grow the memory. It's supposed to garbage collect that. So there's definitely a bug somewhere. Fine. Native by name. Oh, wait, by the way, I'm also doing the by name here. This is really slow, probably, right? To do that. The fact that I'm doing string lookup by name every time I try, for example, to add numbers together, I'm doing string lookups. But, yeah, 10 gigs. Yeah, we're using more than 10 gigs. Something like around 13 gigs, I guess. Or something. But there is a reasons for that. My language right now doesn't have arrays. As you can see, it's my to-do list. I did not implement arrays yet, which means that I'm using for my lists so that I can like do the indexing into into arrays. I'm mimicking my arrays right now using a trip data structure, which is adding a lot of overhead, I guess. It's better than like than having linear complexity when looking up at the index in an array, I guess. But it's not constant time. Yeah, and my interpreter is generally slow. That the OS collect the garbage after the proc dies, but then then it means that I need to like launch a separate process for every line of input. I guess that's doable. What do you think is the actual issue though? How do I figure out the actual issue? I mean I need to like print. I need to print things. If I print things, then we are going to see the issue, right? So we do perform the Gauss, right? So I just need to look at the brute force, right? Yeah, let's just say over here print brute I is equal to string x. Yeah, how about that? So we should be seeing it doing the brute forcing, right? Holy shit, look at this. This is slow as... I don't know. Wait a second. Look at this. It's starting from scratch. Why did I say brute 1 is 2? Oh, wait. Wait, what? Hold on. There's something wrong here. Why did it say brute 1? Do you have threads yet? Actually, I was thinking about that. Yeah, that's one way to speed it up. If I actually do more multi-threading, I can like add the native function that implements the forking easily, I guess. But then it's probably going to there's probably going to be other problems because of like race conditions somewhere, I'm imagining. But we can launch multiple casts. Yes, that should work. Why do I go back to 0 here? Force, I, and max. Transpile to JS, always an option. That's actually the plan, like I said. Yes, my first compilation target is probably going to be JavaScript. So we can like compile to JavaScript, run through Node, and that's just how we can get a faster language. Yeah. So we set 0 to 81, and then we start 1 be equal to 1. Something is really wrong here. I feel like this looks like a, I don't know. Like, because this should, oh wait, but because I is 0. No, that makes sense. But why does it do brute 1 then here, right? Because then that should never happen. Oh, wait, no, it's because, okay, so there's 2 free variables. We started with variable number 1. We set it to 0, and then we iterate over the, yeah, that makes sense. So what is actually slow? Just checking is really slow, right? Just checking is really slow. Well, I mean, hold on. Yes, how do you check? It's not print. So we have 3 free variables, and each of the variables can be like up to 300, around something like that, right? So the complexity is something like 300 times 300 times 300, but every time we like brute force this, we also need to check. Then checking is the size of the matrix, right? Which is around like 10 by 10 or whatever, right? So this is my actual complexity right now, and plus the interpreter overhead, which is like 1 billion or whatever. Right? How do I... Wait, what? Can you, like, calculate the variables faster? Without, like, going through the full metrics? What problems do you have? Not a lot, but, like, I'm just, like... As you can see, every single check is running forever. Right? So every single line is a single check. I'm just checking that the so the free variables, their sum should not be greater than the maximum. And also, while I'm calculating the answer, I'm quitting early if while I'm calculating like the variables that I already know the value of, if their sum is greater than my current answer, then I don't even continue calculating the current answer. Go row by row. If one row is invalid, I break. What do you mean row is invalid? Aren't all rows valid? If it's negative or non-integer? I mean, yeah, I already do that, yes. So, yeah, so like we have 3 variables which we set using the brute force, and then the pivot variables, we calculate them one by one, and if some of them is less than 0, then we just stop checking altogether. That's all you got? Okay, so this is literally my solution. Okay, I mean, we can wait, maybe it will finish running tomorrow, if it doesn't eat my all of my RAM here. I have 7 gigabytes available. Hold on, look at this. This is my gigabytes. This is my free RAM. It's going down. It's going down. I have 6.6 RAM left. 6.4. What's going to happen to the stream when it goes down to 0? Have you tried dividing max by 3? No. You did it on an accident? How do you do that? Hope you have some swap. No, I don't have swap. Free 250 megabytes. Hold on. I'm crashing this shit. Stop. Okay, back to 8 gigabytes free. 12 gigabytes available. Nice. I need to find a memory leak, I guess. Fix performance, fix memory leak. everything that I can do. Is day 10 actually the day that I can finally not solve with my language? Actually, maybe we should actually work on the transpiler instead of fixing the memory leaks and performances. Transpile to JS. That's an option. I'm just not sure why am I leaking memory. You just divide and know what do you mean? How do I do that? Where do you divide? Where do I put the division? I do a very weird iteration because I thought it would help, but I'm actually just stupid. The p to the maximum x 0 to 3 equal 3, then p. So you start at p if free variables, if the amount of free variables is 3. Wait, what? Wait, is this bash? Bash has a ternary operator? No way. P. Oh, x is less than or equal than p. Wait, what? But why? What? That makes no sense, though. Can you explain this? Can you explain this? So basically, it's erased like this. Um, it's it's just iterates like that. Okay. Right. What time is it? It's pretty long time. That I've streamed already. How do I solve this? I need to like either do some like good check or I need to fix the language. Well, I mean the fact that like there is nothing here that should be leaking memory at all, right? All we are doing, like I'm literally not doing anything here, right? Right side values also change linearly when you loop over one free variable. So you don't need to resubstitute all the variables. That's right, that's a good one. I think that's, I mean, yeah. The free variables, they are usually at the end anyway, right? It could save a little bit though. Maybe. In case it's not like that. Um think a little bit. How is your solutions, Shishimara, working? I mean, I guess you did not get to. You're still doing the day 5 or something in SED. I'm wondering who is having bigger performance problems, me or you. I can also like because I already calculate the current answer, right? When I'm doing this brute forcing, some of the things don't need to be checked because like this some of my free variables maybe for some reason is already like bigger than the current answer, you know. You know. Yeah, like how about this? I say current answer is equal to 0. I don't add the free variables here at all. So we add the performance here. Instead, I say over here that current answer plus equal x. But then after finishing the recursion, I'm going to say that current answer minus equal x. So I'm going to revert this. I'm going to maintain my sum of free variables. This is like a tiny optimization, but maybe it can do something. But then I also need to undo my variables, which are not free, right? So I need to iterate over pivot, pivot, inner variables, var row, a list at this. I'm just going to say here something like current answer minus equal. Well, I mean, but then I cannot return here, which is yeah, instead of doing this, I'm just going to save the current answer. Let save is current answer. Current answer is save. Okay, that's a huge optimization, right? Right? Maybe? Is this faster than before? I think it's faster than before, right? It's still really like very, very, very slow though. Why did GuiBot say nice? Because there is a 69 somewhere inside of that message, I guess. Yeah, I see it. It's there. I'm on A5, yes, part 1 done in theory, but it's too slow, so I need to optimize my SED-lib. A5 wasn't that resource intensive. They're doing the advent of code in SED. So everything is resource intensive, I guess. I got to 12 already. Can I solve at least like one line? Can I at least do one line? And I'm also running out of RAM. That's right. My cast is using 10 gigs right now. Oh, wait a second. I have two cast binaries right now. One is using 5 gigs and one is using 9 gigs. I guess one of them is my LSP. So my LSP is also leaking memory, right? Is what it looks like. What if I restart my LSP? If I restart it, it's no longer in the top. I just freed like 5 gigs of RAM. Okay. Okay, let's see. I feel like I just need the profiling here, right? So once again, the profiling data suggests that I'm doing inference unification at runtime and not at compile time. So unite data, this is the inference, right? This takes 50% of my time. The other 50%, I don't know. I mean, like, allocations take 25%, right? So, like, I'm allocating a lot of shit. And then call garbage collector is another 25%, right? So, allocating, collecting, and inferencing, right? Is that correct? So why am I doing inference at runtime, though? That's the question. Because, why would it be doing that? Why would it be doing that? So I have eval, right? I have eval. This says, I mean, just evaluation is 15% though. That's including the children, right? So where? And this is list iterate. Iterate, check, unite, yeah. Add, compare. Is there base check, unite? Map add, map add, map add. Yeah, but why? Wait, what's check, unite? Check, unite. Check, unite is this thing. Check, unite. Add var. Add var value map. We have my recurse ID. This. Check unite, find root. Check unite. Data recurse ID. This. Data on unite is check unite. So this is just some. This is just me subscribing to unification, and then I add stuff to the map. And then of course Twitch scene has been amazing. Just keeping up with the channel surfing has been like a full-time job. Way more nerds than expected. Yeah. But the question is, who is doing the inference at runtime? That's the question. So, like, it is during evaluation, right? It is during evaluation somewhere. So it is from the interpreter. Why, my question is, why don't I see the interpreter? So this is the interpretation, evaluating, right? So I'm evaluating. Most of this is evaluating the expression. Then that makes sense, right? It's just 15% though. Calling a function is high up here. Maybe I need to do something like Perf report no children. Is that going to do something else? Map add, do some marking. That's the garbage collector is doing the marking, right? Map val, ID compare, apply, check unite. Eval. Yeah, it's all inference. Why is it the inference? How do I figure out who called that function? Why is it so difficult? Inference check unite. Like, who called this? That's probably the old data. Hold on. Just file. Can I like do this? Okay, so the inference. There we go. Who calls it? Who calls that? Can I like invert call stack? Check unite, iterate, unite data, function, will run stack, compare, because I'm adding. So like I have a huge map. Well, I'm guessing I'm having a huge map somewhere, right? I'm having a huge map somewhere. Oh wait. Wait a second. Is this the one? Hold on. I feel like maybe I know where. It's in the natives. Natives of the interpreter. Because I'm doing over here, right? That there you go. Expect tuple and stuff, right? No, not expect tuple. Wait, what? Where? Where? Not the RNG. To string. Value await inferred. No. What would be the one? Maybe like this, the binary operator. Let's take the implementation of the binary operator because I'm using math there, right? What I'm doing here is we have a native function. We have a native function, and native function is implemented like this. And over here, I'm expecting inference. So there you go. This is the inference that's running at runtime. Every time I try to get a native function, I'm like, yeah, that makes sense actually. I need to cache my native functions. Like I need to do this thing. I need to do this thing, but I need to do it only like based on the current function, I guess. So like when I'm when I have, let's just do this simple example. Look at this. Let me show you. I guess it is very easy to do the thing. We can have an example. Lots of math dot ks, right? We can do this. Use std prelude. Let's add this to workspace, I guess. Examples, lots of math, right? So what we do is we just do for like let x be 0, and then we do a loop. Let's just do while, I mean, yeah, let's just do loop. Let's just do loop. Loop x plus x or whatever. That's all. That's all that we do. Let's try running this. I mean, fine. Let's say, let's just actually say, you know, this for x in 0 to 1000, and we don't do anything even, right? So let's do cast examples, lots of math. Very good, because there's still lots of math here happening, I guess. Let's do 10 to the power of 6. Right? So just this empty loop, 10 to the power of 6, is running for this long. It's still running. And is it leaking memory? I don't see it. Oh wait, it's Dune. Yeah, Dune. This is it. 2 gigabytes of RAM. 2 gigabytes of RAM for this loop. Okay, I guess like this is something that I need to figure out and fix. You don't know how cast type system works? Can you add explicit type cast to go around the problem for now? So the problem is that I don't do monomorphization right now. So I mean I can have a workaround, but like I can go to like one of the previous versions of my language, I guess. I already reverted, but yeah, I don't know. It's still going to be really slow though, I think. I'd rather just fix it here. It's just like a lot of things that normally happen just at compile time are still happening at runtime. Yeah, but I'm supposed to like, it's still running. There's no way. Wait, it's used 6 gigabytes already. Wait, is it like infinitely leaking memory? There's no way it's this slow. It's probably like the memory leakage and the performance issues are connected, because last time I fixed the memory leak, my performance also went it started to working a lot faster. It's like I'm creating a huge map somewhere of IDs or whatever, right? According to this performance perf report, and looking up becomes slower and slower. So like it just ended. It's used 7 gigs of RAM to just do this thing. Yeah, let's do a little bit. Let's do 10 to the power of 4 so that we can see just running for a couple seconds, right? But this should be literally instant. Okay, so now I can like profile this. I can profile like this, and we will see the same stuff in the report, right? Yeah, just inference, right? So why is it the inference? Well, I mean, I can yeah, it's because I need like this type here. Oh my god. Yeah, so here's the solution. I think so I have this thing which is called call untyped function, which means that I'm calling a function. Value untyped function, maybe compiled function, which has a compiled function thing. Right? No, it's probably like actually on the value untyped function. This value untyped function, whenever I call it, so the function, every function has its body, which is compiled. Right now, the body of generic functions compile only once, and I want to keep it that way, right? But like we are, like in case of like natives, I want to not evaluate them multiple times. So I need to like store the cache here or something of like natives or whatever, you know, like expressions or something. Like I want to store for every expression like the calculated value, maybe, you know, like map ID, map from ID into the value. So for every expression we will be able to say what it is, value untyped function. So I put that here, right? Implement any. I will. I actually will, but that's not going to fix the problem right now. Like I cannot just remove this like inference that's happening at runtime right now because like I have functions like parse, for example, right? And this function, like what what it's doing is depending on the type inference, right? So if I say that if I'm trying to parse and I'm assigning this to an integer, right? Then it needs to parse an integer. If I'm assigning this to an int64, then it needs to parse an int64, which means that, like, yeah, just why is it happening at runtime though, right? Is the question. Because I don't do monomorphization, that's why. So like this is implemented as a native function, and native expressions are always evaluated at the thing. Does it only happen when looping over untyped calculations? No. So the problem is basically this. Let's be support, right? So can I the problem is this. Here's my here's my for syntax, right? Syntax ks. Syntax ks, right? So my for syntax over here, it's just implemented as a macro right now, right? So it just becomes this. So the two important things here is the less than and plus equal, right? So we start at the start, and when we go to the end, and we just add this, right? Then plus equal is just like, so we use the plus operator, right? That's the most important part, the plus operator. So what's the plus operator? Plus operator is just a function, std op add, right? With two arguments being the arguments. So what is std op add? Right? std op add is this, right? So so I need to like evaluate this expression a lot of times. This is an expression which needs to evaluate this expression, a native plus, because addition is implemented natively in the interpreter, right? So how do we evaluate this expression, right? So we have calculated at compile time that the type here, because this is a generic function, that the type of this native plus should be basically like two arguments of type t, and it should return t, right? But t is not a concrete type yet, right? So I need to replace t's with the actual types, which is like an int32 in that case, right? But I am doing that right now at runtime because I don't do monomorphization. So I basically do a monomorphization at runtime, I guess, every time instead of only once, if that makes sense, of this specific expression. And that takes like a long time. And I need this to figure out what is the concrete implementation of the plus that we need, right? So we need to basically monomorphize, but only once here is like the thing. So, which is why I'm going to store. So like this is the function that we are compiling. This function, we are compiling it only once, and this is the expression, right? But when but then my generics are also just technically just functions. So this is a function that's returning a new function. So for every instantiation of generic, we actually create a new function, but I keep the body, which is still the generic compiled body, basically, right? So when I evaluate the generic compiled body, I'm just substituting in place these variables, right? But I only need to do that right now for native functions, I guess, right? So I will instead store for every function that I create the map from a native expression to like the actual value. So we actually calculate it only once, which means that I also will not be doing the string lookup, because right now I'm doing the string lookup in the native map in the interpreter. Like, what does the plus mean, right? So I will just do a single lookup in the map by ID of this expression, I guess. And the map is going to be stored in the in the function value. That's the idea. I probably could like optimize some other things the same way, but let's start with that. Let's start with that. So yeah, we have untyped function, which has the natives. I want to call this I don't know. I want to have a better name. What is the better name? It's just not natives, it's calculated natives, maybe, you know? Calculated natives. All right. So when I'm evaluating the function expression, this creates a new function, and because that's a new function, I'm going to initialize the new native thing. The new calculated natives is going to be ID map empty here. This thing, by the way, must be mutable field, I guess. Mutable. Sure. What about our values? I feel like our values are really cast-like. Does that mean inferencing takes O n square in a simple loop? Yeah. I mean, it's probably not n square. It's not n square because I'm storing maps. Maps are like logarithmic. I don't like do the checking with everything, but the only reason it's logarithmic is because like I'm constructing a huge map, so like all the inference variables, they like know where they come from, so like I store that information, but I'm doing that like a lot of times, and that leads to me having a lot of data stored, which leads to the memory leak and performance issues, I guess. Makes sense. Our values are very cast-like. What do you mean our values? We have L values and our values. We call them place expressions, the L values. And just our values is just values. But yeah, we have that already. Okay, and when I evaluate expression generic, that's kind of the same thing, I guess. Calculated natives is ID map empty. Unbound module, beautiful. Let's quit NeoVim. It doesn't work. I mean, not with the NeoVim, but OCaml language server. Okay, we have generic type, boolean type function is this. What is that? Oh, that's like a new one? Okay, sure. Calculated natives is ID map empty. I could do a hash table, but whatever. I already did that. What is this? This is transpiling in the OCaml. Calculated natives ignored. Okay, success. So, but I'm not using it yet, right? So now in the interpreter common over here, when I'm evaluating expression native, right? This over here, this is a function that takes the type. This type will be like this is the expression native. So every native expression, this one should have an ID associated with it. So we'll have an ID here, ID, right? And then I'm storing based on this ID inside of the function is the idea. So we evaluate expression native, we have ID. So I am going to match. So now I need to like calculated natives. You know what? Let's actually make a hash table. Create. Because I will need to like save this, and this is going to be like part of my interpreter state, I guess. Value hash table t ID value. Hello, and Simil, hi. Another random question: why do people use tree-based maps or hash-based ones almost exclusively in cases like this? In a functional programming language, when you like, it's because hash tables rely on mutability, and a functional programming language, you want to not have immutability. So like doing mutable things is against functional programming, I guess. The immutable data structures have the advantage that you can easily like save the previous version, you can like go back to the previous version, you can like sometimes parallelize things easier. Like if you don't have mutability, then it simplifies a lot of things, I guess. What is the extension is using to show comments? What comments? The extension for Confetti is the power mode. Unbound value hash table equal. Yeah, you know what? This. And to ignore the comparison here, I guess. So this is going to be, instead of ID map empty, is going to be hash table create. What I mean is a reference that has a lifetime defined by the reference, not the variable. The reference has a lifetime defined. Yeah, thanks for the bits. Galileo, good luck and cheers. Thank you. Thanks for coming and seeing me suffering because the language is not complete. But that's why we do the advent of code. We want to like improve and catch the things. That's more fun than just writing tests, right? That's basically writing tests, but yeah, we can use the advent of code later to see if like it actually runs in less than a second eventually instead of an hour and stuff. Expression native ID is ID generate. So I just generate a new ID here when I'm compiling the expression. Okay. Ignore the ID. Maybe all my expressions should have IDs actually, now that I'm thinking about it. Probably would make sense. Maybe I like cache something else for other expressions too. Oh, it's a success. Okay. So now in the interpreter, once again, evaluate expression native. Oh, wait. Yes, there's another thing that I need to change. I need to change my interpreter state. Interpreter state. So now I should have like current function. So like it's similar to scope, but it's going to be like current function natives, right? Which is going to be the ID and value hash table t, right? Like that. So when I create the interpreter, we start without a function. So current function natives is just hash table create, I guess. Create 0. Okay, back to interpreter command. So now we and then when I call untyped function, so I'm changing my interpreter scope here, right? Evaluate new state. So in my new state, I'm changing the scope, and I'm also going to change the current function. Natives is going to be equal to function calculated natives, right? There you go. And now we can use that when I'm actually evaluating expression native, right? So we have ID here. I'm going to match state current function natives hash table find opt. In this hash table, I want to find ID. And if we already calculated it, then we just return the value. But if we did not calculate it, when we actually do calculate it, right? Then we actually do calculate it. So yeah, I say over here that, you know, let value be this. And then I'm going to store it after calculation into the current function hash table. So we just do add natives ID value, and there you go. That's going to run. Let's see if this is going to actually work properly. Cast examples, lots of math. Okay, look at this. It's now instant. It's now instant. Is it actually going to work though? Like, did I break any other language? 2 plus 2 is still 4, right? So I'm going to assume that it works. Use std preludes. I mean, let's just do cast examples, guess. I mean, hello world, right? Hello world still works. And how about guess a number? We say like 5. I guessed. Nice. 6, 3. Okay, seems like guess a number and hello world still works. So I'm going to assume that it works. How it works is if you have a local variable, you send out the value out the reference. The var outlives its purpose, but the reference holds the value. What do you mean? What are you trying to say? What are you trying to like? It's not how it works in C++, though. In C++, the reference does not hold the value. The reference is just pointing to the value, right? So when it goes out of scope, you try to use that reference, you are going to have a segfault or whatever. UB. Do I just I mean, I'm also right now in detached. Yeah, I'm also in detached because there was the performance issue. Wait, but I can undo that. I cannot do that though now. Hold on. Can I like stash and then check out main and then stash pop? Because it's going to work, right? I have this over here though. So the only thing that I added is the substituting of the bindings, but now we can do that easily because now we are caching this thing and this is not going to be a performance bottleneck anymore. Okay. Yeah. Yeah. Accept both changes. Not exactly. Not exactly. And to substitute the bindings here before doing this, right? That was the change from here. There we go. Cast example, guess a number. Okay, cast examples, lots of math. Okay, nice. Exists since C++20 is a reference. That's called move semantics. It's not a reference anymore, right? Or like, I don't know what they call it. C++. Our value reference declares our value reference. Okay. Yeah, I don't know why would I need it though. Because it has move semantics. That's about the move semantics. I don't know. C++ is weird. I feel like Rust does it a lot cleaner. Move semantics, I don't like how it works in C++ at all. Because they need to keep the original value where you move, which you moved from, still in the valid state, which leads to performance overhead actually, which is not zero cost, which is against C++ core values, which is weird. No? But yeah, I'm just saying that I'm just going over here. I'm just going to fix this, right? Fixed natives doing inference at runtime. Well, we do it once now. Committing is not possible because I have an unmerged stuff. Git. There you go. Okay, let's do this. Let's update the language and see if this works in the advent of code. Just update cast. What if it's going to actually run faster than Bash now? Okay, this is almost instant now for the example. What about the actual input? Well, the brute forcing is still really slow, right? You're waiting for the faster than Python moment for my language? Yeah. No, Python is pretty fast. I would need to, like, I feel like to become better than Python. Like, does Python do jitting? I don't know. Let's remove the brute force logging. Verb is false. Where is the brute force logging? Free variables. Whatever. Brute. This does not print it. So I have 6,000 combinations. How long does it take? 1, 2, 3, 4, 5, 6, 7. I believe you can compile it. I mean, yeah, that's the plan, but the interpreter, I mean, yeah. Not the entire not the entire language can be compiled, right? Because like treating types as values probably is not a thing that should not be compiled, right? Like in Zig, the types, they only exist at compile time, which makes sense. So yeah, something like that. So machine number 11. Okay, hold on. It's already 11, so I already did 5%. 5% in 1 minute, right? So we just need 20 minutes, correct? Wait, hold on. This one, this is the slowest one. This is the slowest one. This one is going to go on forever. Am I leaking memory though? Or am I not leaking memory now either? Like, I don't see my memory going up, indeed. The top memory user is the OBS. I don't see cast up here at all. Cast? Wait, where's cast even? Am I using any memory now? Am I using 0 memory now? Can I search here for cast? Wait, it's using 3 megabytes? No, 100 megabytes. There we go. 100 megabytes. This is the bash wrapper. And this is the actual binary. 100 megabytes. Yeah. This is the one that's actually running. The 100 megabytes is my language server. 68 megabytes is the actual solution. Okay. But is this one going to take eternity still? Probably. I want to try, like, when we have lots of math. Example here. What if we do this much? Literally, right? But without even doing anything. How long will this take? Like, you see, just iterating here is still taking a lot of time, right? And I'm doing some other operations there. The leak has been defeated for now, yeah. Until another leak emerges at some point. Like, this should still run in less than a second, for sure, right? So do I keep... maybe, oh, hold on, let's just profile again. That's what I should do, just profile again. Let's do 10,000. So 10,000 is less than a second. 100,000 is going to be 4 seconds, right? So let's profile that. Just profile this. Finished it, but mostly with 2 stars. Cool game. Wait, what game? What game are we playing? Oh, the Beat Golf game? I'm assuming. Okay, what is this? So this is just eval now. Now we have literally evaluation at the top, which makes sense. So this is just because I'm evaluating. I guess at this point, maybe. So there is no inference now, which is something that I like. Printing. Wait, hold on. This is weird. Why do I have print of the source I up here? 20% of time is used for printing the source. Source. Print. Like one of these prints. Somewhere. So I'm printing something to a string, maybe. Because I was not printing anything, right? Yeah. Probably printing something to a string. Somewhere. It still is working. Okay. I feel like I will not be able to wait for it. Source print. Output ACK. Output ACK. Yes. 30% is just printing something. This is the STD format. Standard library format. So which who is calling that? URI path inner. URI encoded of path. I'm printing the path, the URIs. Okay. As I said before, print. Yeah, but like if I'm not seeing anything on the screen, it means that I should not be printing anything, right? Because I'm not redirecting my input, my outputs anywhere. All my printing is like normally behind logging, but maybe not everywhere. Maybe like make string. If I'm printing to a string, then I should look for make strings. Oh, cast profiling begin. There we go. This is it. It's because I do profiling. Hold on. I understand now. Profiling should only happen if I actually do this, you know? So begin should have a function that calculates the name, right? So name should be a function. Name is name. I think this makes sense. Yeah, it's because like this is my own instrumenting profiling of the cast code itself. So, and this is where I'm printing my my things. Yes. So instead we do a function which returns the string, so which is only going to be evaluated if profiling is enabled, right? And I think that's all. That's just like the 2 lines here. So let's see. We were running 3.8 seconds, and now, if I do it after it's compiled, like this, and now it's 3.7 seconds still. Okay, maybe that's not it. Oh wait, no. It is still it because like I need to do that only if match out with none, then I just return immediately. But if it is some, then we do that, right? There we go. Yeah. .9 seconds, so 4 times faster. Okay. I like these numbers becoming 4 times faster. Do I keep profiling? Do I keep profiling? I should keep profiling, right? Maybe like go bigger number here. Let's go for 10 sec. I mean, yeah, let's go for 10 seconds just so that like we don't like calculate the compilation time at all. And this is still working. Well, I mean, if I like, I should just stop this. It just these 4 times is already going to be faster if I restart this, right? Perf report. All right, now what? We have tuple. We have array maps. Scope finding the thing in the scope. Find local inside of a scope. Okay. Iterating the lists, eval and okay. That makes sense. So just evaluation. Let's do perf report, no children. Literally just evaluating, but that function eval place, find locals. Or a function claiming find root var. I'm not sure if I can improve this further though. I don't see anything here. Is find on? Yeah, I guess it is. Like I should fix that. Yes. I mean it's not on. It's all depth of the current span tree of the current like scope, right? So I'm trying to find in the current scope. If I don't find it here, then I find in the parent scope. Finding in the single scope though is logarithmic over the amount of variables in a scope. I already convert those to IDs, so I'm not doing like string lookups. I'm doing just like ID lookups. But I might like need to go to the parent scope multiple times to find the actual variable. So just eval place. Eval place is basically literally when we see, I guess it's not necessarily always a variable, but yeah, they're just finding a variable in scope is 5% of my time. Maybe like find, yeah, it's 13% of the time, right? Yeah. I'm making my own language too, but it's very tiny for my programming puzzle games. Do you use your own lexer, parser, and work on the AST to the interpret? Yeah, I write everything from scratch. I'll work on AST to interpret. So like I have this stage of compilation, which I call compilation. What I so like my parser parses the syntax tree, which is not abstract, right? It's like concrete syntax tree. I still call it AST though. Maybe that's wrong. I don't know. But yeah, we parse the syntax tree, right? And then that syntax tree is being compiled into, I guess I call it intermediate representation, but maybe that's what actually is called ASTs in proper compilers, right? And then I interpret that. Yeah. But what I'm saying is that it's like I can show you a little bit here, right? So here's my types. Here's my expression, right? So I guess this is the AST, although I call it intermediate representation. Right? So this is my language basically, right? We have constants, references, claiming places, like statements, scopes, functions, generics, tuples, variants, and all of that, right? So that's what I'm interpreting. But this thing already has like all the type information available. So it's not just the syntax here. We have everything. Is it still AST then? I don't know. I don't know the theory of programming languages. So my expressions, they store the data, which includes like the span where it came from, like in the source code, and the type, which is already inferred when I'm evaluating. And the parser is outputting something very, very generic. So my AST, which probably should be called something else, but like I say, the AST is very, very simple. It's either a token, it's either a simple token, or it's a complex thing. Which was generated using a specific syntax rule. So my parser is very generic. We can create the syntax in the program itself. We can extend the syntax. Yes, the language has extensible syntax. If you look at my current solution for the advent of code, then the first line is introducing the new syntax for iterating over the range in reverse order. So like you can have your own syntax extensions. So and then like through the macro system during compilation, it's like extending this. And this is technically just a normal function which like returns the AST. So we have an interpreter running during like parsing, I get during compilation and stuff. That comment to the right that says you 2 weeks ago, I'm not sure if it's the thing of the... No, it's not. That's just the I feel like this is the default. This is like the git blame, maybe the git lens extension or something. That's not connected to the power mode at all. Let's just say improved performance. I don't know what else to improve. I didn't see anything, right? You're using Antler to generate me all of this C++ code, so I don't need to write it myself and write the grammar using regex. Well, I mean, I also write the grammar, but I like... So when I want to introduce a new syntax, I'm literally just doing that, right? So here's my syntax definitions, right? This is the definition of a very simple language here, and like... This is the actual language over here. So I'm just... for my parser, everything has an expression. I give it the priority and the definition, and then it just parses that. And then the compiler knows what some of these syntax definitions mean, basically. What does KS stand for? It means the cast, which is my programming language. Yeah. That's how my language works over here. We have like compilers and like syntax and stuff, you know. All right, let's do Nix. Update cast again. I kind of like want to print how much is done there though, but I don't know if that's easy. Let's just run. And see if it runs. I mean, one of the other things, by the way, I know how to improve the performance easily. There is another thing which is very similar to the natives, which is being interpreted every time, which is literally generics, right? I'm trying to evaluate what my generic is all the time. Yeah, so like once again, like this code is still going to be going faster, because if we look at the std operator, right, we still see this code. I mean, not in this code. I guess this code is now relatively fast, but this is a generic function, right? And what we do is in the syntax of the plus operator, right? What we do is we call this function. This has an implicit like generic argument. So this is called instantiating a generic here, which also means that I'm evaluating what this means. So I'm trying to find this in scope first. Every time I try to do an addition, this I guess is why I'm doing that all the time, right? std, I'm trying to find that in scope because I'm evaluating this. And then I'm trying to find the field up there, and I'm trying to find the field add there, and I'm trying to have this as a generic and instantiate it. But we are going to just find the already made instantiation in the map, so it's not like that bad. But I mean, in this case, this entire can this entire expression just be cached, like the value that we evaluate this to? Can it? I mean, in my use case, yes, but not always, I guess. It can, I mean, yeah, can I like have over here something that resolves at runtime? Potentially. So if I add that optimization, it might break. Maybe. Maybe I cannot do anything about it right now. But I mean, some of these, they basically like for example, this expression. This is an expression. It does not need to be evaluated multiple times, right? But how do I know if an expression needs to be evaluated multiple times or not, right? For example, the expression a. Well. Whether this should be evaluated depends on the actual expression, I guess, too. Mm. Syntax. What does my report say? The profiling. Just map of the mapping of the tuples here is high. And array mapping. Array mapping is part of the tuple mapping. And finding the thing. In the scope. But STD is a constant, like, right? STD is a constant. Am I looking it up actually? Am I actually looking it up? Let's see, compiler. Is a struct part of functional programming, the C type? I don't know what you mean. What do you mean the C type, the struct? So like the struct like in C? I mean we have structs, I guess. They are a little different. Maybe, I don't know. I mean, which functional programming language are you referring to? Like OCaml here? We just say something like, you know, type s is, you know, x int 32. In C, you would say like struct s int 32x, I guess. This is kind of like the same thing. Not exactly, because like the OCaml is garbage collected, but I mean, I don't know what your question is about. Specifically. Mm-hmm. Like this is almost like constant propagation, you know, because if std is a constant, then std.cmp we like obviously is also a constant, and std.cmp.less is also a constant, right? But like let's just do this, you know. Let's do something like this: cast compile examples, cast compile examples hello ks, right? So we can see the actual like thing that I'm compiling. I'm using dot star where used is this constant, yes, but what about let's go back to hello world, right? So how about this? I say std, let's just say 2 plus 2 and see what this compiles to, right? So this compiles to instantiation generic of me reading the place where place is object. So we binding std, right? This is not a constant. Std is assumed to exist as a value at runtime, where we get like then the field add of it, a field op and then field add. Then I instantiate that with argument being an int32, and then we apply that function with the argument being a tuple with 2 2s as 2 arguments. In C++, a structure is just a class with default public params and stored consequently in memory. Yeah, that's maybe a little bit too much information for functional languages usually. They don't care about the low-level details that much. So it's not guaranteed that stuff is consequent. I mean, I guess like technically it is still consequently stored in memory, but it also is storing it behind a pointer automatically, I guess, because everything is boxed in OCaml here. So, like, as you can see, this is the thing that I need to evaluate. While in reality, what would I want to evaluate is just that the function, we already know it, right? Because this std is constant, so std.l is like everything here is basically constant, which could be evaluated at compile time, right? Or at least we can also like do constant folding at runtime, but that requires knowing that an expression was constant, right? So how do I know that an expression is a constant? JIT. Yeah, basically. Just in time compile const. What's this called? Const propagation or whatever. First of all, like the fact that this is a binding, I'm not sure if that's what I want here. So this means that when I'm evaluating this, I need to look up what std actually is. What's the value of std? And like over here, we're going to like try jumping scopes multiple times in order to find it. And I need to look for the fields. Okay, how do I do that? Interpreter. Here's when I'm creating my std. I create the std. An interpreter with std is the interpreter which has the std. And so the compiler has the binding, right? Scope inject binding. Let's see, what is the compiler scope even, right? So compiler scope is different from the yeah, I guess in the compiler scope everything is a binding, but I guess some of the things which are constants can be staying constants instead of me referring to them as bindings. Yeah, that makes sense. Actually, that makes sense. So like, so during compilation, we basically treat everything as a runtime value. But I could treat this as either a runtime or a compile time value. And then we would compile this where std is already a constant, right? And then later, because I guess we could do something. Maybe I actually do it during compilation then, so that I don't do it even just in time. I do it literally during compilation. I have an expression. Can I evaluate this right now? And then I do it. But that's not always possible actually, because I cannot do it during the compilation always, because sometimes I have generic variables. So that would require monomorphization to actually calculate some of the things. And once again, something that we don't want to do. The advent of code is still running on the machine number 11. This is the biggest one. How long is this going to take? A lot. Well, I mean, by the way, fixed memory leak is kind of like fixed. Performance, like, kind of half fixed or whatever. Erase would improve the performance, by the way, of my advent of code a lot too. We still don't use erase. I feel like there's like a lot of work though. Maybe I just keep this running. Maybe I just keep this running. You know, like it's been a while. I need to stop streaming. You know, maybe I just keep it running and then I will like have the thing calculated tomorrow and and I submit it tomorrow. Then you know. If it's not leaking memory. If it is still running, still using 67 megabytes, it's not leaking memory at all. So, yeah. Just keep this running and then submit later, I think. Rewrite in faster lang just to check it's correct. The solution? I don't know. I mean, the solution is the same as like the other people's solution, so we could have a bug while rewriting, I guess. Finish performance idea, look at some Karmix code for idea. I have a lot of performance ideas already. I don't need more. There's already a lot that I can do. The biggest one is literally just compilation. Transpile into JavaScript is already a performance upgrade. And then we can compile to native code. Ask GPT to do the conversion. You think ChatGPT can understand my code? I mean, let's see. Let's see. I think it's going to do it easily. That's how we do compilation to JavaScript. Compile, transpile to JavaScript. Thanks. Transpile from cast to JavaScript. Best effort. Still is transpiling. Using ChatGPT as a compiler is, yeah, is one way. What was that statement about Rust in the beginning? Oh, it just was saying that I should have transpiled to Rust instead of JavaScript. Rust is faster, right? 1,000 times easier if I was using Rust. Let's do calculator task.js. Input txt. Part 2. No such file or directory. Input txt source day 10. Input txt. Okay, okay, I think it did not do it correct. Answer. Wait, hold on. Wait a second. Wait a second. That's not correct though, is it? There's no way. Wait. It actually transpiled first try to JavaScript. It ran in less than a second. And yeah. I'm surprised actually. And like my logs are basically like same as like it did like the things properly almost. I don't, yeah, like everything. The matrix is not assignable to type null. I mean, yeah, there are some issues I guess here, but it actually works. That's impressive. Yeah. Okay. Transpiling to JavaScript is the way. And yeah, transpiling should be relatively straightforward, I guess. I mean, I don't have any generics in my code, I guess. Do I? Do I have generics? I don't. I mean, I have swap, for example, right? How did it transpile swap? I mean, this one is very easy though. In this one, you can just do type erasure. Yeah. But like, yeah, for the most part, transpiling to JavaScript will literally just do type erasing anyway. Where am I looking? I want to look here. When you ask for some GDescript, you had to rewrite it, but I guess I asked for an older ChatGPT. Well, I mean, JavaScript is also the language that is like the most used. So the fact that that ChatGPT can do JavaScript the best out of all the other languages would probably make sense, right? That's why I chose JavaScript here. Otherwise, for faster runtime, we could do some like C++. I mean, can it do C++ or like, I don't know. And I would need to install the compiler and stuff for the things. Interesting part is that it's new in its cast. Okay, well, I mean, that part is understandable. Same as the fact that it was telling me about Rust. That's part of my customization here. It knows that I'm making a programming language, basically. And it knows that life is easier with Rust, normally. Before my language exists, actually. Where's swap? So it literally just skipped transpiling the swap function because it's not necessary, I guess. Where am I using the swap? Over here, right? A lat row. If j plus 1 is less than m, pivot push. Yeah, this thing. Swap rows. If non-zero row is not equal to I. So yeah, it's just doing the swapping in place here, I guess. But that's how you would do it in JavaScript, I suppose. Makes sense. Whatever. ChatGPT even knows about every small each game prototype it had an incoming visit. You had an incoming visit from it in one of your prototype? Yeah. All right. Well, I mean, that's great, I suppose. I'm not going to commit the... I mean, maybe... should I save this JavaScript code? I don't think I should. I mean, sure, I will save it. Just in case. For some reason, someone doesn't believe that my cast solution is correct. Chat GPT transpiled. This was a cheat though. Yeah. Can you ask it to transpile your SCD solution? Oh, by the way, I'm already... Wait, hold on. My cast solution is already at 111, by the way. So I'm 50% done. We can wait, okay. How long was it? Just like 5 minutes maybe? 10 minutes? So like 10 more minutes and it's going to finish? Right? Right? 124? 130? Okay, hold on. There is like just a couple of like big ones, and this is smaller than the one that we were waiting for at number 11. Yeah. Mm, mm, mm. What I'm wondering is like if I go the transpiling to JavaScript route, right? Because my next goal would be to do the self-hosting of the language. If the language that is transpiled to JavaScript is like the compiler, that is basically is the transpiles to JavaScript compiler is going to perform well or not. Probably no reason for it not to perform. That's another big one. That's probably not as big as the other one. This is like 1, 2, 3, 4, 5, 6, just 7 digits. Well, I mean, this one was also 7 digits, but this one it was almost 8 digits. I did like this. Let's swap rows is if rows are equal, then mad, else array map I. I feel like in your implementation of swap, your swap implementation there is really slow because array map I is basically allocating a new array entirely, right? Even although you're just doing the swapping. Also, you're doing arrays. Arrays are mutable. Wait, or is array map I is doing in place in OCaml? I don't know actually. I feel like it's doing a new one, right? Array map I. Yeah, you want to do map I in place maybe. I don't know. Maybe there's actually probably swap. No? Is there no swap? No. Well, arrays are mutable anyway, right? The immutable one is the list. And in array you can do in place. You can just set. You can mutate it in place, right? So you can implement your own swap. Which is constant time. Easy. The ChatGPT added comments to my code too. How nice. Last column is joltages. Huh? Fill columns with button. It understood what I'm doing here, yeah. Gaussian elimination, best effort port of cast. Matrix class. Do I wait for this to finish? I mean, we already have the correct answer. I just wanted to check that it actually does the correct answer. What's the appeal level camel say compared to Rust? I haven't tried a camel yet. Well, I mean, the appeal level camel to me is the compilation time, because I was writing my language originally in Rust, and I have stopped and I have rewritten it in a camel because I had the problem with compilation times. Otherwise, I think Rust is a better language. But if you are into functional programming, then you might like OCaml more, I guess. But I don't know. Yeah, you know what? I'm just going to end anyway. Like, what are we doing? It's going to give me the correct answer. We already know it, right? We already know it. There's no reason to wait, even though it's probably going to finish in like a couple minutes. Let's just go somewhere. There you go. OCaml. You wanted to learn OCaml? This person is learning OCaml. Thank you guys for watching. See you next time. Bye.